In this one, we are going to be covering Python Pandas. This is a fantastic tool for handling spreadsheets and tabular data, right? So like if you wanted an alternative to Excel and you wanted to use Python to do it, you can use Pandas. And it's actually a very common tool among data scientists. And I use it all the time for prototyping web applications as well, like the actual data I need, how to clean it, do those sorts of things. Now that's what we're going to be doing in this one. We're going to learn the fundamentals of Pandas using practical application. We're going to go ahead and use NBA statistics. That's the National Basketball Association statistics to just really get familiar with this tool. I think it's so much of a tool like Excel. Like if you opened up Excel and just did a standard little spreadsheet, you're probably not going to get a whole lot out of it. It's not until you actually dive into a real project that you're going to start getting a lot out of it. And so that's what we'll be doing in this one. Let me know if you have any questions. My name's Justin. I'll take you step by step through this one. And there's also a reference book for this. You can actually go through all of the notebooks that we're going to be doing that I'll talk about in just a little bit. So let's go ahead and get started. All right, so I just want to do a quick overview of the things you need to know prior to jumping into this one. I expect you to have some experience with Python. Like, can you write classes? Can you make functions? Do you know what string substitution is? Can you do some basic math? Those things are really important. If you don't know how to do that, check out my series, 30 Days of Python. It is on cfe.sh. Now, the idea here too is we have all of this reference code. So when you get stuck, be sure to check out the reference code. We are going to be adding this to our environment that we're going to learn in. But the idea is to always check the reference code when you're getting stuck or having issues. Of course, Stack Overflow and several other sources on Google are able to help you diagnose some of those problems as well. Now, if you have any questions on this, let me know. Otherwise, let's jump right in. Now we're going to go ahead and set up our project, and we're going to do this using interactive Python notebooks. I'll explain what that is in just a moment. But before we do, I'll mention our GitHub repo right here. So if you go to this link and navigate to the Try Pandas repository, you'll find all of this code in here. And there actually might be more than what you see on the screen right now. But the general idea is you want to make sure that you have this course folder inside of your local project. Everything else doesn't really matter that much, but the course folder does. We will absolutely want to have that specifically because in here we have data sets that we're going to end up using, as well as sample data that's also in here that we'll end up using based off of some of these notebooks. Now, I will say that everything we do in the video is not going to be perfectly matching with what's in these notebooks because after the video is done, I'll probably make updates to these notebooks themselves. So this will be the best place to actually get the latest code that's related to the notebooks itself. And of course, if you find errors, please submit an issue or a pull request so we can make that a little bit better. But with that out of the way, let's go ahead and actually set up our interactive notebook environment. And of course, we're going to be using Deepnote. Now, Deepnote is the sponsor of this series, but what they do is they allow you to run notebooks interactively with real-time collaboration. And my favorite thing is Docker environments. We can actually control the entire environment. That's what got me on Deepnote in the first place. Now, there's many other reasons to use Deepnote, but having your own control of the environment is like, whew, that's so, so nice. And that includes adding environment variables and stuff like that to help make things a little bit more secure. But anyways, we're going to go ahead and use that now. Jumping into the repo, I'm going to go ahead and launch this project into Deepnote. Now, it's important that you do launch it into Deepnote so that you have your own version of all of this code, as you'll see right here. Now, if you've used other notebook environment, it's not going to work this easily, right? It can work, but it's not going to be this easy, and it's not going to bring in the entire project itself. It might bring in one single notebook. So yet another reason to consider using Deepnote, and plus it's all free too, especially with what we're doing here. Of course, if you start to get more advanced, you might need to upgrade your account, but for the vast majority of us, we can do everything in Try Pandas for free. So I will say, before we go down the rabbit hole of using Deepnote, I will say that I have a way to set up the open source version of running notebooks, which is called Jupyter. Jupyter itself and Deepnote both run the Python notebooks, right? So the PyNB, these are interactive notebooks that allow us to run any block of code. Now, for those of you that are already well familiar with that, yeah, I get it. We're talking about things that you already know. But if you don't know about it, then running these notebooks is a really, really nice tool to have in conjunction with Pandas, so you can rapidly iterate, but more importantly, you can see the results from what's happening in Pandas in line. You don't have to jump in and write Python or run a command constantly. You can just do it in this notebook, which is why I highly, highly recommend that you learn Pandas in notebooks. So if you actually go through the Jupyter one of it all, you can install a very similar environment on your local machine. But the cool thing about this actual Deepnote is that I can share it with other people. Anyone on my team could actually come in here and run notebooks themselves. But then also I can actually run these notebooks on my phone too, which is something I've found to be really, really useful as well. All right, so now that our project is in Deepnote and it's ready to roll, let's actually get into the lessons. All right, so jumping into Deepnote, we're going to go ahead and create our first data frame. So be sure to open up the folder over here for notebooks and files, and we're going to go ahead and create a new folder, and I'm going to call this NBS. Now, that's a very common way to name where you're going to store your notebooks on any project. Now, I will say, of course, the course directory or course folder has a bunch of notebooks that eventually we'll sort of go through, but I'm going to be doing it just a little bit differently inside of the NBS file itself. Now, the reason you're going to want to watch the videos is I'll give additional context that might not be in those notebooks themselves, but the reason you'll use those notebooks is they will be the ones that will be updated from time to time. Anyways, so inside of NBS, we're going to go ahead and create a new notebook, and then we're going to go ahead and do one-DataFrame. Okay, so the data frame inside of Pandas is a way to control an entire table that's columns and rows. There's all sorts of things that are cool about it, but that's the general idea here. So the first thing that I want to do is just set a number of some kind, and I'll give it a 10, right? And so what I want to do then is say data equals to, well, a list comprehension. So for X in range 0 to that number, right? And so what this will do is give me, well, let's see, how many items are going to be in here? It should be 10, right? And it should also correspond to those numbers. Not a big deal here. So to actually use Pandas, we can import it as Pandas as PD, just like that. That is the convention, much like NumPy and many other data science libraries. And then we can actually do df, as in data frame, equals to pd.dataframe. Okay, and then from that, we actually pass in this list here. And then to run it, we hit Shift Enter or Control Enter, depending on what system you're on. You can also just click Run Notebook and it'll run the entire thing. But now we can actually do df.head, just like that, hit Enter, and this will give us a glimpse of the data frame itself, right? Really, really not that complicated of data here. Now, what I want to do though, is I actually want to have better data. I want to have a little bit closer to like what realistic data might look like or what we would hope for. And that is not just a list of numbers, but perhaps a list of dictionary values. So I can say, number and have that equal to X, and then maybe added by and put the string of Justin. We can add additional items in here as well, right? So if I imported date time, I could also do some sort of time, so let's say the time or the date. I'll just go ahead and do time as datetime.datetime and .now. And so now we have quite a bit of a different data set, right? It's giving us the key value pairs on any given dictionary value here. Now, those key value pairs, of course, are essentially saying, hey, this is the column name, right? So if you've ever used the built-in CSV writer with Python, you'll know you can actually write out a CSV file, comma separated values file from dictionaries much like this. So what's cool about this is now that I have this data, I can initialize the data frame again, and now I actually see it has numbers, it has time, it has added by, right? So it actually gives me the column names corresponding to any given dictionary value like this. which I think is really, really cool. It's like an easy way to sort of grab that data or initialize that data. Now, what we're going to be doing is we're going to be going through this a lot and expanding quite a bit. But what I can do also just right now is data.toCSV and just say, temp.csv and run that. And that will actually create a CSV file for me inside of my directory here. Right? And then I can open this thing up and actually take a look at the CSV files. Now, I'm actually not going to use this. I'm going to delete it in a moment. But that's actually just a quick and easy way to not only take a look at our data, but also to have an actual CSV file coming in with that data. Now, there's a lot of ways to export data from Pandas itself. You can export it to an Excel spreadsheet, which would go into an actual workbook itself or a sheet name itself. And so there's, like I said, there's a lot of things that we can do that we want to really discover here. But as we see, it's a really, really easy way to initialize data inside of a Pandas data frame. Now we're going to go ahead and take a look at importing and exporting data so we can move around different kinds of data sets. So let's go ahead and create a new notebook in our MBS folder. And we'll go ahead and just call this import and export. Okay. So in here, what I want to do is first off, create some random data. So we'll go ahead and import random, and I'll also import pandas as PD. And I'll go ahead and say items equals to an empty list. And then we'll get a random number. I'll just say number is random.rand int, and we'll do 0 to let's say 10,000. We don't want this to be too big, especially as we're testing things out. But you definitely don't want it to be too small either. Otherwise, you won't get enough random data. And so I'm going to go ahead and iterate through here. So for x in range by doing a loop of these numbers to really just create our data set here. And I'll go ahead and say dollars equals to random.rand int. This time I'll give really big numbers to what it could potentially be. And of course, using underscores in place of commas. So we have those big numbers. And then of course our data, and here is going to be our player name. And we'll just go ahead and use some string substitution and make the player name based off of the number that's being iterated. And then that's, that range that's being iterated rather. And then player salary is basically based off of that dollar amount string substitution. So we can just put in the dollar here. That of course is not going to be actually formatted at all. So I'll use $ here, and then the colon, comma to have it as comma separated values, and then .2f to turn it into an actual dollar amount with cents in there as well, even though none of these will have any cents. So now I run that, and that should be dollars, not dollar, and then items.append this data. Okay, so that's going to create that data set for us, and then of course our data frame is pd.data_frame of those items. And then we can take a look at it with df.head, right? There we go. So now we've got random salary. And of course, if I run this again, right, it's going to clear out everything because I have clearing out the items there. I run it all, the entire loop again, and then df.head. Now my salaries are certainly different. Now it's pseudo random, right? It's not going to be perfectly random, but this is the point, is to really export this data and then import it. So I'm going to go ahead and show you what we did before, which was to CSV, and we're going to call this example.csv. And then from there, I actually want to read it. Granted, I could open it up inside of Deepnote, but since I have pandas right here, I can just say df2 equals to pd.read_csv and example.csv. And then we can take a look at that, df2.head. And what we're hoping here is it's going to map this data perfectly. But what we'll end up seeing is, well, slightly different data. And that is this unnamed 0. What is this column, right? Shouldn't it be the same here? Now, the reason it looks like that is because we're saving this data to a CSV file, including the index value here. So in this case, the index value is just a number that's incrementing per row, right? So at the very end, the last row in here, that would be that index value, right? So let's actually take a look at what I mean by that. And so we're going to go ahead and create a new block of code here and do df.shape. So df.shape we'll talk about more later, but this will show me the number of rows and the actual column itself, right? And so each column or each row that's happening here will have a number that's corresponding to it, right? So when we do df.head, we see 5 rows and 2 columns, not all of the rows. If I do n equals to whatever that shape is and run it, it's now going to give me all of this data. And I can actually expand this inside of Deepnote. Not all notebooks allow you to do that. It does slow down the performance quite a bit because it's starting to now have a lot of data in memory. So do that at, sparingly, basically. But what we see at the very end is 2195. That's the index value of 2195, which is very similar to saying, let me scroll up here to the last block. It's very similar to saying that if I created this code here and grabbed that number, which was the df.shape of 0 minus 1, we can actually see what that data is. Another way to look at that exact same thing is just to use -1. Okay. And so that gives me that index value at that spot. And so this time I'm going to change the n being back to 5. We can also see the tail of it as well, showing me those also, right? And so I got player 2195. It's giving me that value. Okay. So df.shape does give us some interesting information, but the point of this is not really to look at that, but to get rid of that index altogether. So we just say index being false, and then now when we actually export it and save it and reload it, we now see that that index value is gone. We're not seeing this random column in here. Because the problem ends up coming up is sometimes we do want to save the index value, but a lot of times you won't, right? And so the problem is that if I actually save this again to CSV of the exact same example, it's going to, it's going to continuously add the index value to it, right? So let's go ahead and read it, run it and read it several times. And then we'll go ahead and look at df.head, and we'll see that it now has all of these new columns in here, which are not columns that I particularly want, right? So this starts to bring in all sorts of issues, and it's as early as importing and exporting, right? That's why I'm spending so much time on it, because we definitely want to make sure that this is false given the kind of actual file that we're exporting to. And so that when we do export it and we read it and save it and read it and save it, we always essentially want to say that the index is false, okay? Especially with CSV files. Okay, cool. So let's go ahead and actually look at the course notebook for this in one Pandas and Datasets. You'll see a lot of the same kind of data in here, but the reason I'm showing you this has to do with, the different kinds of data we can export to, right? So we can use a TSV file, which is tab separated values, which is also very common. Notice that I have a separator here. The default for that is actually a comma, right? So the actual comma separated values uses a comma here, tab uses /t, which formats to a tab with Python. And then we've got this Excel version, right? So we can declare the file name for Excel and then the sheet name. Then we've got JSON, HDF, HTML, a pickle file. We can use SQL Alchemy to actually store this in a SQL engine. There's a lot of different ways on how we can export it. With that, to actually import it, it's basically the inverse of that. From to CSV or to Excel, we do read Excel, read JSON. The biggest difference is we're using Pandas directly when we need to import it, and then we're using the DataFrame directly when we need to export it, right? So that's really the gist of using importing and exporting. Now, in my mind, I don't think you should remember exactly how to do all of the to CSV options, right? So there are more options than what we have here. I also don't think you should remember to JSON exactly. I remember personally when I first started out was Pandas export to CSV, right? And so my thought is, how do I use Pandas to export to CSV? And so that's where I got, it's to CSV. And then how do I use Pandas to import from CSV? Now in my mind, it should be actually pd.from CSV, but of course it's not. It's read CSV, right? Which makes sense as well because it's going to be reading a file or even a data type that has CSV files, right? So again, it's not about remembering how to export it specifically. It's remembering that the data frame itself exports it, and then Pandas can import it, and we have a lot of data options for that. And of course, those are referenced as many places as you possibly can find them, including on the Pandas documentation. Now we're going to go ahead and learn how to rename columns in our data frame. So inside of MBS, we're going to go ahead and create a new notebook, and we'll call it 3, rename, and columns. Now, you're probably wondering, why even rename columns? Well, what I'm trying to do is actually get us thinking through all of the ways to clean our data. So we want to actually rename columns because if we look at our example.csv, this is not very Pythonic, as in player name and player salary. Notice the space in there. Sure, it might be human readable, but it's not Pythonic. So what we want to do is make it Pythonic. And instead of using our local MBS examples, or example.csv, we're going to go ahead and use the one from the course itself inside of samples. And this is going to be 1.csv. We'll probably use 1.csv a couple of times. So for now, I'm going to go ahead and import pathlib. And then I want to actually get that data set. So we'll go ahead and say our base dir equals to pathlib.path.resolve, and then just print out what this base dir would be. Hit enter. And of course, it says work/mbs. So the base directory for this particular module is inside of the notebooks folder, right? That's what it's showing me. /work is done by Deepnote. So if I do .parent, what I should see is the root of this project, which of course would have MBS and course. So I could say MBS dir equals to that base dir/MBS. And I could also print out whether or not, that exists. Just like that. Cool. I love pathlib. This is part of the reason. So now I'm actually going to go ahead and do my course dir. I don't need the notebooks dir. I need my course dir. So it's course. And yet again, we do exists. Now I need my samples dir. And that's going to be course and I believe samples. So we just break that down and there it is, samples. Great. We're going to use this a lot. So make sure that you've got this done correctly. Okay, so now that we've got those directories set up, let's go ahead and import pandas. So I'm going to go ahead and import pandas as PD. And we're just going to go ahead and do df equals to pd.read CSV from the samples dir 1.csv. And then we'll do df.head. Okay. So what you should see here, assuming I did the imports correctly, you should see the player name with that space and player salary. So we're doing the incredibly easy task of renaming these columns. So how is it that we go about doing this? Well, we do something called df.rename, and we can pass in columns equal to something different. So I can actually pass in key value pairs here. So if I say name is equal to new name and hit enter, I actually don't get an error. And in fact, it returns back a data frame, which we'll talk about in a second, but it still has the same column names in here, right? So if I rename it to something different that actually maps this, then I will get that column changed, just like that. So before I go much further, what I can do is I can create a new block of code here. I can actually do df.columns, and this will give me a list of those names, right? So I can say columns equals that. And then let's say auto changed equals to the list of those columns, right? And so this will include an index value, of course, as in player name is always going to be at position 0. And so I can do x.lower and .replace the spacing in there with an underscore for x in that column name here, and end it with a parentheses there. And then renamed or mapped columns is going to be equal to the dict of zipping these two things together, which will be columns and auto changed. And we can look at this as well. Okay. And so this is, of course, a automated way to do this. This right here could probably be improved quite a bit for other kinds of ways of formatting these column names. I'll explain that later. But for now, I'm actually going to put in the manual version, and I'll just call this map columns equals to that value. In fact, I actually don't want it to be player name. Instead, I want it to just be name and salary. Okay, so let's do manual map columns or custom map columns. All right, so now I've got this dictionary. Long term, this is definitely what I'd rather do. Short term, while we're learning, we're going to use the manual version, and then I'll come in here and paste that in. And what do you know? Now I've got my column names and stuff like that. And it even gives me, a glimpse into what's going on with that. But if I come down a little bit and do df.head, what I'll see is the original names. Now, this has to do with a property that Pandas has by default, which is let's not modify anything on purpose, right? As in, let's not change the data frame on purpose unless the user, that is you and I, tell it to. So one of the ways to change this is to say in place is true. So what that means is then it's going to run this function and it's going to change the original data. It will modify the original data. I can hit enter and then enter again. And now I've got that new modified data. Now, another thing that can happen is this right here without in place, we can actually say new df is equal to that. So this actually returns a new data frame, which is why we saw a glimpse of it before. Right, so let's go ahead and read that data again, just to make sure that we do have that original data without the map columns in there. And so my new data frame is going to have this renamed data, whereas my old one has not changed, right? It's still the same. Now, this is very common to do inside of Pandas, is to use the results of a function like rename, like another one that we use, which is called apply. It's to use it in a sense that we don't want to modify the original data all the time. Now, this hopefully makes some intuitive sense that you don't want to modify the source data. Instead, you want to modify some new data. And that's the point of this, right? So we modify new data and use that going forward. And then, of course, if I still wanted to use the df variable, I totally can and just say df equals to that new df.copy. Something like that. And then that is how I can actually come about using this new data frame, okay, with the new named data. Now, of course, I left it out with something that we still need to clean. And this is what we'll do in the next one using basically picking up from this actual notebook itself. But the idea here is we cleaned the column names. Now we need to go ahead and clean the actual data itself, which is this dollar amount. So let's go ahead and take a look at that now. All right, so let's go ahead and copy our rename columns notebook. So I'll just duplicate it and I'm going to go ahead and rename it. And this time it's going to be clean rows. So we'll go ahead and say for clean rows. Okay. So renaming columns is also like saying cleaning the rows, right? And so the reason I wanted this is for our original actual data frame here and then our custom mapped columns. So some of the automated stuff I'm going to go ahead and get rid of. And I don't need the data frame head there either. Okay, so I'll delete this cell as well. And there we go. Okay, so let's go ahead and run this notebook. Let's just make sure that I have all that data with the renamed columns, because actually grabbing the columns themselves is going to be something that I'll probably want to use in the near future. Okay, let's go ahead and get rid of that as well. Okay, so I've got my data frame here and that's the original one. Let's get rid of that one. There's our final one. Okay, cool. Rename columns. We're ready to go. So how do I actually get all of the data in a column? This is actually really cool. And it's df, the brackets themselves, and the column name. We hit enter, and this gives me, well, it will give me all of that data. This is actually what's called a series. So if I do type and take a look at that, this is a Pandas series. So a data frame is just a collection of Pandas series. So that collection ends up turning into a column, right? So that series is a column. So there's a lot of things that we can do on a series that doesn't necessarily work on the data frame itself. One of those things is just doing values, right? So what values will do is turn that series into a list of data, right? In this case, it says array, but just consider it in your mind as a list. If we really want to make it a list, we can just wrap list around it in Python, okay? And so the index values for this list correspond to the index values in the actual data frame itself. For example, player 0 is at index 0. If I look at index 0 here, I can actually see this right here, right? Same salary, okay? So that's actually really, really important. And also, if I do tail and do, -1, I should see the same value that's here should be the same value that's here. So where these things actually lie in relation to their indexes or indices is really, really important. Okay, so before I go any further, what is it that I'm trying to do with this data, right? With this actual column? What I want to do is actually turn it into a float. You could turn it into a decimal as well, but I'm going to turn it into a float because it's a little bit less complicated. But the idea here is we actually need to format this string as a float. So if I actually look at this data, let's go ahead and change this to my salary list. I'll get rid of the index value here. And if I try to get any item in here and turn it into a float, what I should end up seeing is an error, right? So first off, the value error happened because this wasn't actually there, but now the value error is you can't turn this string into a float. Okay, so what's the way to do this? How do I actually turn this string into a float? Well, let's go ahead and copy this currency value, and I'll say currency str is equal to that string there. And so to turn this into a float, I need to get rid of the $sign. So let's go ahead and do replace and $sign to 0 or to nothing really. And let's map that whole thing into a float. So I'll go ahead and do current, let's just say float of the current str, run that again. And yet again, I've got a problem. And that's because of the commas, right? So let's go ahead and do replace, and I'll replace the commas now with an underscore. Okay, run it again. And what do you know? Now it actually is a float number. It's a floating point number. So I can say current, dollars is actually that. And then with that current dollars, I can actually do some math on it to get some sort of value, right? Now, I think this is actually really important when it comes to working with data, is you want to make sure that you can actually perform math on integers. If it's a string, of course, you're not going to be performing math on it. But if it's a number, you want to convert that data type correctly. Cool. So what we can do is, of course, change this entire list, my salary list. We can change all of the items in there into a string of the actual floating point number itself, right? So I'm going to go ahead and say my salary list and then cleaned. And then we'll basically just run an iteration through that list, the original one. So I'll go ahead and do, first off, just the list brackets here. And we'll say X for X in that list. Of course, this is just copying the list. Now what I can do is actually replace everything in there. And in fact, I can turn that whole thing into a float. Cool. So this, of course, is just exactly what we did before. And then we turn it for every item in that list. And we come back in here, and it should be cleaned up, or it should be floating point numbers now. And what we should also see is, 0, the first element there, the first index value, is going to correspond directly to the first value in the data frame itself. Okay, so this list has to be the same length, because now I'm going to go ahead and create a new column, and I'll call this salary cleaned, and I'm going to set it equal to that list. I'm going to hit enter, and then I'll do df.head, hit enter, and what this will show me is that data cleaned up, right? What do you know? And it is a data type of float 64, as you see from the data frame itself. We'll talk about that more later. But these numbers should correspond all the way down, right? Which I think is a really clean and easy way to do all that. But is it the best way? And the answer, of course, is no. Okay. So what I want to do now is I want to actually take a look at one other aspect of this, which would be let's go ahead and take these values, and instead of putting the list in here like this, I want to just go ahead and approach it one other way. The more appropriate way, which would be the salary cleaned to, and I want to actually base this off of another row. That other row, of course, is simply salary. Okay. And so what this does is it will copy the row, so df.head, or copy the column rather. So salary cleaned 2 is a direct copy of salary cleaned 1. So what I can do is on a series, so remember these are called series, the columns are series data, I can run something called .apply. .apply can also be run on the data frame itself, but if I do it on the actual series, I can do, well, a bunch of data or a manipulation on that series. So what I can say is, let's actually scroll down a little bit. I can now create a function up here, say clean salary data. This will take in the actual value of that data, like of that column. Let's see what that looks like, and then I'll return back that value. Okay, so I'm going to just call apply. So I should print out a bunch of stuff. I'll get rid of that head, and I'll run it. And now I see literally every value that's coming in from that apply. Now this actually will take a while. The reason being is because I'm actually printing it out. If I don't print it out, it doesn't take nearly as long. So if I said my new value now is equal to the float, well, essentially, if it was equal to this right here, right? Instead of X, we use value and run this again. What's going to end up happening is df.head salary clean 2 actually has the correct data in there, right? Should be actually cleaned up as far as what is the data is concerned. Oops, we should return back the correct value. And notice how much faster it is than before, right? It actually does, it's actually a lot more performant this time around because I'm not printing it out. But now we have that clean data as a float. So those are two different methods on how to go about doing it. Which is the correct one? Well, it's going to depend on, well, a number of factors. One of them being, where is it that you're actually cleaning this data? In my opinion, I actually end up using this method more often than not, so that I know for sure it's running off of, a pre-existing data set, something that's already in there. Now, here's where the other thing comes in, which is the incorrect values, the incorrect number of rows. So let's go ahead and see how you might actually trip up on this. And that's going to be, first off, we'll go ahead and say rows length. If you remember, df.shape will actually give us both the column length and the row length. And it goes row length and the column length. All right, so it sends back a tuple of that, or a tuple. And so, of course, I can look at that, and it'll give me the actual number of rows that are in there. Oops, we don't need parentheses there, just .shape. Okay, so it gives me the number of rows here. So if I actually changed my, let's say, new rows being row length divided by 2.0, and let's go ahead and just turn that into an integer. So dividing that by 2, this means that I'm going to have some empty values here because it's half the length, right? And so I'm going to go ahead and say new column data is empty. And I'll just do 4x in range 0 to new rows. And then I'll just go ahead and say that my data, let's just put in, actually we'll go ahead and put this in here. And we'll just use that number. Okay. And so now I'll go ahead and say df.new data to that new column data. And of course, you could also just say true in here as well. It doesn't really matter what the actual data is. But now if I try to run this, what I should get is a value error, right? So length of values does not match the length of the index. The index is literally twice as big as this, right? And so if I added it in twice, then perhaps it would actually end up working. But that, of course, is not the correct type of data at all. So this is where pandas can be a little bit like finicky as to how we end up doing something with all of our new data, right? With everything that we might want in here. which I think is important to note. It is important to understand that adding new data needs to match certain parameters. In this case, it's matching the actual length of the rows itself. So that's why I actually think getting a list and then just adding it to a data frame is not the way to do it. Instead, using the actual column method, what we did correctly, the actual speed of apply. Now, there is one other thing that I can do in the terms of, this random data, right? So a random list here. I can actually use apply on my entire data set. So let's say apply on df. This time, what we're going to do is pass in the row, and then I'll return the row itself. Okay, so now I can say row and random df or random data. I'll just go ahead and say 12. And now I can actually run df.apply and apply on df. Notice it's on the data frame. We're passing in a function here. I want to pass in the access being 1, or the axis being 1, so it actually runs on the rows itself. And then we can actually see the result of that. Okay. And so this will give me yet another way to actually add in data. So this row here is actually series row or series data, much like as if we were grabbing the column, but this time I actually have access to the entire row instead of just the column. So it's name, salary, salary cleaned 2, new data, and so on. So anything that would be in that row would be available here. And it's going to take some time because it's doing the entire data frame and each row. It's going through each row individually to update that row and then returning what that update would end up being, which again will take some time depending on how big your actual data set is. And so now that it finished, we actually can see that random data in here showing up. And if I do df.head again, what am I going to see? This is definitely something for you. Is that new data in there, right? It's not. And that, of course, is because of in place. We never did in place being true here. If you did in place, it would have changed the original data frame. That is yet another place for that. Instead, what it did is it returned back a new data frame for me. This is why I'm seeing this data right here, which I think is actually a really good thing. That df.apply, when you do something on the entire data frame, it doesn't modify the entire data frame. Pretty cool. So the other thing is when we do need a new column is we can actually run something else, which is, let's say, for instance, df and let's do, 1/2 salary, 1/2 salary, right? Or let's just call it half salary. That's a silly name. Okay, so df half salary will be df and salary cleaned, and we'll multiply that by 0.5. Look at that. I hit run, df.head, look how fast that was. And now what's going to end up happening is half salaries in there. So it performs math very, very quickly, especially when we clean it correctly. So in this case, I actually didn't have to do .apply and running that. How would we actually do .apply in this method or something similar? If you forgot times 0.5, well, you would just run it as a lambda. So I'm going to go ahead and do half salary again. And then we could do .apply. I could pass in a function or a unnamed function as in a lambda. And I can say lambda x is x times 0.5. And I can run that. And that will give me basically the exact same thing. But of course, I'm actually modifying the original data frame with this by adding a new column in there or replacing the old one, right? Really, really cool. So there's a lot of ways on how to clean our row data. What I tried to do here was show you a lot of the methods or the approaches to actually solving that problem by also learning a bit more about how to add data to a data frame. So hopefully it solved two things in your mind. Of course, if you do have questions, let me know. But I will say that some of the cleaning features I actually do have as a utility function in the course itself. So if you look at the course itself, we'll probably end up using some of this in the future. But this gives me a utility function of things that I can actually end up using for my entire project. A good example of this would be float to dollars and then dollar string to float, right? That was done on purpose, so it's not as manual every single time, but then I can also update this in the future if I were to need that to be improved. So by all means, add this into your project now because we probably will be using it in the future. Now we're going to do some basic analysis of our cleaned data. So be sure to create this new notebook and implement a new data frame using these parameters here. This is something that we should know pretty well by now. And so what you see in this data set is this salary as float and then also the player name. That's kind of the key here, is we want to use the salary as float and the name. So what I'm going to do is actually change this from df to simply init df as an initialized data frame. And then we'll run that. And then below here, I'll go ahead and say df equals to initdf.copy. So what I'm doing is making a copy of this data frame instead of referencing that data frame directly. Using .copy is really good for when you need to take only portions of a data frame. So to take a portion of the data frame, we need to say what columns we're going to grab. So the columns I want are going to be name and salary as float. Now, if you remember back, if I just did something like this, this of course is a series then. It's almost identical to saying just the original data frame and name. Right? So that would give me a series, or otherwise known as that single column, right? So if I copy it, what I can do is I put that into a list itself. Now it's going to treat that series as a column in a data frame. So in other words, this is now a brand new data frame with only this column. So if I wanted to add in another column, I would add that in as salary as float. And there we go. So now I have the columns I want, just those columns. And so another way to approach this would be to say columns would be those columns. And there we go. And then df.head. This will now give me roughly the same data, but just with 2 columns. Now the reason for this is really just to narrow down our data based off of really the raw data that we were originally working with, but now we have float data instead of that string data. Cool. So now I'm going to go ahead and declare the number of rows here. So the number of rows is equal to df.shape and the first element in it. Remember, it is rows and columns. That's what comes back with df.shape. So getting the first element there will give us the number of rows. Now, what's the reason for this? Well, the reason is to actually calculate the mean, or the average salary as float. So how do we actually get that? First off, I can go ahead and say salaries equals to the list of the data frame of salary as float dot values. Okay, so there's our salaries. And that would give us a bunch of float numbers, right? What I can do with that is I can say the sum of those salaries is equal to the sum of the original list. And then the average of those salaries, well, there's 2 ways on how I could do it. First off, I get the sum of the salaries, and then I could divide it by the length of the salaries, or I can divide it by the number of rows. Both should actually give you the same value. And then I can actually print out the average salary, not salaries, but average salary. And there we go. Okay, so this of course is using a lot of Python features, right? So that's okay, but what we want to do is actually use built-in features into Pandas. And it's really easy. Average is equal to that data frame and average, just like that. And so this will give me the average of that. Or rather not AVG, but rather mean. Mean is also the average. So we've got our average there, and this will do the same thing. It will actually be a little bit more efficient than doing it this way, especially because what we're doing here is turning it into a list, and then we're summing everything up and then dividing it by the number of rows. Okay, so that's pretty cool. Now we can also do the sum, right? So I can go ahead and say the sum is equal to that. Let's go ahead and say the df sum Okay. And so yet again, it's doing that as well. This time I can again divide it by the number of rows, right? So it's still giving me the same value as far as the average is concerned, but that is definitely an option I could use, right? Which is pretty cool. And so I can also use the mode. So we'll go ahead and say df mode, and this is going to be roughly the same thing, and then just dot mode. And the df mode, or the value here, is going to give me a range of numbers that is most commonly used in this entire list. Now, in this case, these won't really overlap, right? They're pretty much going to always be the same, but it does return a series. So as you see, there's an index here. So there's a series of data that's related to what's going to appear most often in the entire data set, even if it's pretty arbitrary, especially based off of this data. We shouldn't see repeating salaries really. Next, of course, we can get the top one. So top salary is equal to our, well, max value. So instead of mode, we can do max. And we can do that same idea for bottom salary. And instead of max, simply min. And then we can print this out as top salary and bottom salary. Okay. And there you go. Pretty simple, right? So now we have a lot of statistical data based off of the fact that we cleaned up our data. Without cleaning the data, we wouldn't have been able to do this. And also we saw a few different approaches to this. Now the min-max stuff could also be applied to that list as well. So there are built-in features for this. But what's going to end up happening with pandas is going to be a lot more efficient doing min, sum, mode, min and max using pandas itself because of how it's actually designed. So it's designed to be a lot more efficient here. All right, so that's it for some of the basic analysis. But now what I'm going to do is I'm actually going to take this data, we'll normalize it, then we'll add groups based off of that normalized data, and then we'll chart it. I'm going to do that in a completely separate notebook. But now we understand at least some of the built-in analysis tools that Pandas provides, because you will use this fairly often. All right, starting in a new notebook, which I called grouping and plots, I'm going to go ahead and use the data we've been using, our name and salary as float, to start to put our data in different forms, right? So the first thing is I want to actually normalize this column. Normalization is actually really, really useful for grouping data. It's also useful for machine learning, which is something I'm not covering right now. But the idea is, how do we turn all of these numbers, instead of having them giant, have them relative to each other between 0 and 1, like 1 being the biggest number and then 0 being the lowest number. So that's essentially what we want to do here. And I'm just going to call it df and salary norm. Okay, and so to calculate this, it is going to be our current number minus the minimum number divided by the maximum number divided by the minimum number. That's the idea here. And so we already have an idea of how to grab those values based off of what we just did. So first off, we're going to use salary as float now. So whatever the current value of salary as float is, we're going to grab that one. Then we're going to go ahead and grab the minimum value, just like that. And doing this same idea with this part here and here. Just like that. Okay, and so this is something that Panda is really good about. It's actually able to distinguish how to set any given row based off of all of this value, which I think is cool. I mean, imagine trying to write all this logic out for each row. It starts to get a little bit messy. So if I do df.head now, what I'll see are these normalized values here. Now, this is going to be a lot better when you use real data, not just random data that I created, right? So now with this, I'm actually going to group this data based off of this salary norm value, right? And so to group it, what I'll do is I'll create df and group equals to, Well, I want to actually base it off of salary norm, right? So basing it off of this means I can run .apply, and we'll call this group R row, or group R rows, or group R data. Essentially, let's make a function that will handle the logic for grouping this data. Okay, and so by default, I'm just going to return the string of mid. The idea for this group column is just to have different values, top, like mid, and then low, right? Or actually, let's call this low. So the idea here is if the value is greater than 0.95, then we'll return top, the string of just simply top. And then elif the value is like less than or equal to 0.95, and the value is greater than 0.5, then we'll return mid. Okay, so now we have a way to parse these things out into a new group, and it's incredibly fast. This is in combination because of Deepnote and Pandas, but Pandas itself is how this can be done so quickly. And so now we can actually use this group to calculate other data, right? So something, for example, I can actually say the data frame of the group and get value counts. Now, what value counts is going to do is it's going to count up the reoccurring values that happen inside of any given column, right? So in this case, it's counting up all the instances of low. There's over 15,000, mid, and so on, right? Those are the value counts that correspond to a value in that column. This can be done with all sorts of things, right? Not a value that I needed to calculate. You know, you could do it for name as well, but name is going to give you basically one for everything, right? So let's leave it in as simply the group so we can see, okay, here are my different groups. So now the question is, how is it that I use this group value and actually see the, the average salary for each group? So that's where the group by method works out really nice for us. So we do df and then dot group by this group at the column name group, right? So group by is the method, group is the column name. And then we grab a specific column, so salary as float, and then we can do mean, and we hit enter. And what this will do is it's very similar to this, except now instead of just counting the number of instances in there, it's giving us the actual value of this. Now in this case, it's not formatted very well. So how do we go ahead and format it? So we can just copy this same thing just to add a formatting aspect to this, and then just do dot apply. And we can do lambda x, and then of course use the string substitution for this, right? So the string substitution to, actually format this would be using x from lambda, or the past value there, colon, comma, dot to f. That would give me closer values to actually the dollar amounts, right? And of course, if I actually put the dollar in here, it's going to show you what the mean value is for each dollar amount at that group, which I think is really cool. This gives me much better analysis on any given group, right? And so I can use this same concept for the sum, like how much is actually in that group? What's the actual value of that entire group? Now, my sense is these numbers are going to be inaccurate when it comes to real data, real NBA data, right? I would actually make the point that perhaps these numbers are going to be closer to being flipped. In fact, the top is probably going to be where this 495 is, then mid, and then the lowest is probably going to be something like that. That's 72 billion, which is crazy. But anyways, so now we can actually see a little bit better of how grouping this data works. But of course, if I go to df.head, one of the things you probably won't see is all of this rearranged into that group. The actual index values, the ordering is the same. This is not sorting this data, it's grouping this data. Pandas certainly has a way to sort data, but that's not something I'm going to do at this point. It is fairly straightforward, and the Pandas documentation does make that easy. And I will say this is actually a good time to talk about the documentation because there are a lot of features in Pandas that you may or may not use very often. And granted, I could probably talk for days on all of the different features, but the idea that we have group by, what we see here, you can actually really quickly search for anything like sorting, you can try that, or sort by, right? Or sort values. And there we go, right? So a lot of the intuition might come out as to what is the actual method itself, or .apply. You can look at that as well. And of course, you could obviously do a Google search for this or even search on the documentation itself. But the general idea is you can actually see the documentation gives a lot of information as to the arguments that you can pass in, but it also will give you an example, right? So if we actually did want to sort the values, here you go. You can do it by specific columns. That's not something I'm going to do just yet. But the point is hopefully well made that there is a lot of data that you can learn from this. But anyways, so now that we have the ability to group our data, what I want to see is a plot of this data, right? So I'm going to come back up to, let's do the mean data here. I'm going to leave it as this without the format itself. And I'm going to go ahead and say that my mean group data equals to that. And I want to print out what the type of this data is. Okay. And it's a series. Okay. So it's not a data frame. It's going to be treated as a series. Now, the series itself has a index value and the actual other values. So these are the index values, and this is the actual value from that index value. Okay, so this also means that I can actually run .plot on here, and I can give it kind of, let's say, bar, hit enter, and this will actually plot out our data for us, right? And it's going based off of the mean values. Now, in this case, it's not surprising that the mean values go up based off of how we group this data anyway, right? We grouped it based off of normalized data. That's not surprising. But now it's actually going off of the actual salary itself, which I think is really cool. But the nice thing to know about plot is this can be done on a series, right? So if we go back into the documentation and go into for series, you should be able to find the .plot method. So .plot, quick search, and this will make a plot of a series or a data frame. This is using matplotlib. So if for some reason your plots aren't showing up, the chances are really good that your requirements.txt were never installed. I have a bunch of requirements in here that I just totally did not even address, mainly because Deepnote installs them by default. But of course, if you weren't using Deepnote and you were just referencing this later, that is probably why. But I think it's actually really, really nice that we can now plot out our data. We can see what this group data is in a much more visual manner, right? I can now see this is how all of my items are laid out. Now, the plots themselves can get really, really advanced here. That's not something I'm going to cover because matplotlib itself needs its own series to really fully get really great plots out of Pandas. Pandas is much more about actually preparing the data to get it to a point where then we can actually plot it out. This is just a convenience way to plot out data given what we are feeding it. So by all means, at this point, go ahead and try to plot out different kinds of data based off of what we know now, so you can really see how it actually plays out. I will say that plotting data is usually best when you're using like actual integer types or floats or decimals. Plotting out the data that's a string, well, you can try and see what happens and see if it actually makes any sense. Now we're going to go ahead and clean a real data set that comes from our reference code here. So be sure to create a new notebook with at least this stuff as basics. And then going into the course, we want to jump into the data set here. And I see that there's the MBA historical salaries.csv file. This data is coming directly from Appendix A. So definitely run that notebook if you want to see how it's all done. But the idea here is we need all of the paths to that MBA historical salaries, and it looks something like that. Okay, and so what I want to do is take a look at this, and I'll go ahead and do df equals to pd.read CSV of that input path, and then df.head. Now, what hopefully won't surprise you about this data is it looks a lot like the things that we may have already done. Look at that. We've got a player name, which in this case it just says player. We've got salary, which is a string. We have adjusted salary, which would be adjusted to roughly today's numbers, and then some year data in here as well. This is pretty cool. So this is actually giving me the data that I need to clean. And of course you might be like, well, how is it that I'm going to go about cleaning this data? So before I go any further, what I want to do is actually go into my course again, the actual reference files, and jump into utils.py. Now, inside of here, I have a bunch of utility methods of things that you may have already done to some degree. One of them is actually doing the string formatting from taking a float into dollars, right? Really simple. Already did it a few times. Dollar string into float, the group salary, idea here, and then this snake case stuff. So what I want to do is actually just copy this and bring the same file into my MBS folder. Go ahead and create a new file and just call this utils.py and paste this in here. There's one little thing that I should have here is value equal to or less than, which is what we actually used in that last part. But now we have just basic utility methods that's going to make it really easy for us to just call this itself. Now, I actually really like this method of working with notebooks because then if I ever need to change one of these things like dollar string to float, maybe I want to change it to a decimal instead of float, I could do that really quickly by using this one method. So that's what we're going to be doing going forward. Going back into our cleaning data here, the reason I introduced that is so that up here, I can now import that utility function. So import utils. It should be able to import it at this point. Looks like I have a syntax error on it on line 27. And that's because I put the equals in the wrong side. There we go. So let's try that again. I'm going to restart this and run it again. And now I should have no syntax errors or anything like that. So when you do need your own Python files, every once in a while you will. This is a quick and easy way to do that. Of course, that's a custom utils file that we're using here. And the reason for that is to just format these numbers right here and not have to repeat ourselves over and over again. And if I ever need to change anything, I will. So what I'm going to do now is say df and cleaned equals to df.copy, then .apply. We're going to do a clean row function. So we need the axis being 1, so it works on the rows itself. And so let's go ahead and create this clean row function. And we'll define clean row, takes in a row, and then it will return a row as well. So remember, the row itself is a data type of series. So this is a pandas series. Okay. So what that means is that I can actually do row and salary is equal to the original row and salary, or a modified version of that. That modified version is going to come from our utils. So utils dot dollars string or dollar string to float, just like that. So this cleaned version is going to be just like our original version, at least with the name of salary, but instead of it being a dollar string, it should be in a float. I'm going to do the same thing for our adjusted salary so that I have both of those things in as a float. So this is a good example as to when you would actually run apply on a data frame itself instead of just one column. Certainly we could still run this on multiple columns, but this is a good example of doing it on the row altogether. So let's go ahead and run that. It will take a moment because it is doing quite a few things, but it shouldn't take too long. So I run dfclean.head, and now I should see those two values as float numbers, and even the columns themselves are of the data type float, which is great. What I will mention though is every once in a while you might have to add this cleaning method to other columns, right? So let's say, for instance, you did have other columns. I could also do something like this where it's salary, salary, and adjusted salary. And then for call and calls, then essentially do one of these, right? So it's actually going to allow me to be based off of the actual original column salary itself, right? And that does the exact same thing, except now if I ever need to change what the columns are, I could just add another one on there if for some reason I had another data point. That's really just it. Okay, cool. And so something I haven't shown you yet, but something that you might do from time to time is checking a data type of any given row or column, rather. So we would say the salary dot D type. And this will give me a data type that corresponds to that particular column. In this case, it will be related to our float. And in this case, specifically, it's float 64, which is a Pandas data type for floats. I'm not going to get into that too much, but the idea now is that column data type is what we want. It's no longer an object or a string. So we can do all of the analysis that I want for this. So a good example of this, of like, how is it that I want to see maybe the number of players per year, right? So I want to actually analyze this data a little bit more because I have a few things related to it. So what I'll do is say players per year is equal to df cleaned, and we'll go ahead and do year start. So I'm grabbing the year start, right? And then I want to do dot value counts, and we'll just say sort being false. Okay. And so what this should actually do, df cleaned year dash start, oops, that's something we probably want to clean as well, but we got year dash start, and this is now giving me all of the players per year, right? So that is certainly one way to go about doing this, where it's actually going to count all the values by the actual year start. All right, so now I'm going to go ahead and grab the number of players per year here. So to do this, I can use either DataFrame, but I'm going to use df cleaned, and then I'll do group by and year dash start. After I group it in the years, I'm actually going to go ahead and grab the year dash end. So I actually get both the group of year dash start and the year dash end in my data. So I can do value counts in here and hit enter. And this will actually give me the number of players per season, really, but I'm calling it per year. And so what we see here is 1990 to 91, there's 352 players, all the way up to the most recent data that we have, which is 2020 to 2021. That's the number of players here. So this is actually pretty cool data, but it actually would be better if I can see it as a graph so I can see what's happening. It visualizes it a little bit better. So we'll do player per year is equal to that data. And then after I run that, I'm actually going to go ahead and plot this one out. So player per year dot plot, and then I'll just give it a title being, number of players per year. And I'll run that, oops, not ploy, but rather plot. What I'll do and what I'll see now is an actual plot of the number of players per year. And it's giving us the group, which of course is the year start, and then the end of that group, which would be actually the calculation that it's doing. Now, something this does not account for at all is if players left at any point in that year, because it's going off of a data set that may or may not be accurate in the first place. But here's the number of players per year according to the data set in Appendix A, the salary data set, it will. So as we see, we're losing players every once in a while. So we get a bunch and then we lose a bunch and so on, right? And this is probably very common in the NBA for a lot of reasons, right? Like teams might have 20 players to start with, and then at the end of the season or the next season, they have 15 players or whatever. So that's actually at least graphing that data. But what we are seeing is seemingly an upward trend. Now, there could be a lot of reasons that account for this, but this chart at least gives us this data, which is quite a bit better than just looking at the raw data itself. Thus, another reason for doing this sort of analysis is to see where things are trending. So the other part of this is, how about our salaries themselves? Where are our salaries trending? And so let's go ahead and do that. I'm going to do adjusted salaries so that they're more relative to today's numbers, not real numbers, not the actual numbers back in, let's say, 1990, because the salary in 1990 in comparison to today is just not the same. So I'll go ahead and do adjusted salaries, and we're going to go ahead and look at this one. And this is going to be, of course, roughly the same data. So we'll grab this group by here. Okay, and then I want to grab the adjusted and salary. And then I'm just going to do our sum. So really just like, hey, how are these salaries going forward? Or we could do the average, so the mean salaries, right? And so again, let's take a look at what that number would end up being. And hopefully what we see is based off of the year. Sure enough, we do. So this is showing me from the start of the year, the start of the season salaries. And the data, I don't have the start and the end. I just have one for the entire season. But in any case, it's showing me these numbers. This doesn't mean a whole lot until I actually go to plot it. So I run the adjusted salaries dot plot, and title being adjusted average salary over time. Run that. And this will give me a plot of those salaries. And not surprising, it is also has a upward trend for the adjusted salary over time. Now, this could be for so many reasons, including maybe the NBA has gotten a lot more popular in recent years, and that's why the average salaries have gone up a lot. That's certainly something that we could sort of surmise or guess from this data. But nevertheless, after we clean it, we can adjust it a little bit and take a look, right? And so you also might be like, oh, well, sure, maybe the average salary goes up, but what about the cumulative salaries? Maybe all of them aren't necessarily going up like this, just the average. And so we can do adjusted salaries sum, and then plot that one out. This time I just won't give it a title, but we'll plot that out and we'll see what's happening there. And it should actually correspond pretty well to what we see in the average salary, adjusted salary over time. Pretty cool, right? So it's very interesting information that's coming out from this. But this also could mean that, hey, maybe we want to see who are the top earners and how do their teams do and all that. So that's an additional analysis that we might do at some point. But now we have a really solid foundation, I think, to analyze and continue to use other kinds of data. So at this point, it's like, well, what is your statistics background and how are you going to implement that with pandas? That's kind of like a key piece of all of this, right? So if you know statistics really well, then you can start actually really getting a lot out of pandas. Now we're going to go ahead and merge two data frames. The data set I'm going to use is the player salaries cleaned, which we just finished doing. And then I'm also going to be using another data set called inflation rate, which is coming from the Appendix B. Okay, so we'll talk about all of these things as we go forward, but make sure that you have all of this imported and we can actually run all of the data frames and get some of the values just like this. So the inflation data frame itself has dates going all the way back up to 1960. So that's the longest time ago for this inflation rate that I'll be able to use to put it into today's terms, into today's dollars. And then also the data frame itself is all the clean data, so I actually can use the float data from whether it's the salary or the adjusted salary. So the point of this is actually to validate our adjusted salaries, to see if those are accurate or not. And that's really not that big of a deal. The point is actually to see how to merge data. But in any case, I'm going to see that I've got a data frame here. The iLoc will give me a index value at the very beginning, right? So iLoc.0 is index value of 0, as in this value right here, which in this case is Patrick Ewing, and it has a salary of, looks like $4.2 million, basically. Okay, So with this salary, what I want to do is I want to calculate the adjusted salary based off of our inflation data frame. So there's actually a number of things that I can do for this. First off, with my inflation data frame, I can actually set the index value based off of the date value. The date value, of course, is a column value, but in this case, it's clearly a date, right? So I can easily turn this into a date string itself, which is 1960, 12, 31, right? So actually running set index will allow me to do that. It will actually turn the entire index for this data frame to a date. So I can say in place equals to true. Now, there's a specific reason for this, and that has to do with how I can actually slice this data. What I can do is I can pass in a year, let's say year 2000 to the year 2001, and this will actually give me the values that correspond to that, which is actually pretty cool. Now, if we actually go back to this iLoc thing, this is actually a way to slice it as well, but it's just going off of 0 as the index. This is actually going off of a date value, which is pretty cool, I think. So what if I did actually 2000 and, I don't know, May 15th to, let's do a different value in here. Let's do May 20th. And I run that. Of course, this doesn't actually give me anything back. There's no value here. So what I want to do is I want to take the original salary here and I want to make an adjusted salary for it, right? So I'm going to go ahead and declare this as OG salary. It's equal to that one. And then the adjusted salary is also close to this one. And it's just going to be adjusted salary. Okay. So what I actually want is the inflation rate for this. So I'm also going to go ahead and grab the year start, and that's going to be equal to this location, and year dash start might be underscore. Let's check. It's underscore. Okay. And we'll do that same thing for year dash end. There we go. Okay. So again, with our inflation data rate, or data frame rather, I can actually grab what the inflation multiplier should be. Okay, so we've got year start here using f-string substitution. And then I can use that same thing for year end. And it'll give us a value. And then if we grab the multiplier value, it will give me that series back. So let's go ahead and do dot value. Series does not have that. So instead, I'll just go ahead and do the float of that data. So multiplier equals to the float of this data. Okay. So now we have a multiplier here, and we should also have our original salary. Okay, so multiplier times our original salary. That should give us, well, maybe the exact same thing. But let's go ahead and do our now adjusted salary and subtract the original adjusted salary. And so I've got it off by about $16,000, right? In other words, my original adjusted salary is over by $16,000. Now, of course, this has everything to do with the inflation data frame itself on whether or not that is accurate, right? So perhaps they're using a different multiplier to get to this number. More than likely they are, because we don't have the exact same number. So in that case, then perhaps they are using year start, +1 and year end +1. Maybe they're using a different year for this. No, maybe it's not +1 here. Maybe it's subtract 1, right? And so what I'm trying to get at here is there are different methodologies to actually come up with what this adjusted salary would be in this case because of how inflation works and also how to find the multiplier. and the fact that the actual NBA season spans across 2 years. Maybe it's actually not going off of the year start, but rather the year end, and that's what their inflation rate's doing. But the point of this is not actually to really argue about the inflation rate or anything like that, but rather to actually combine this data so it's not on just one user, but on all of the users. So now that we've laid this foundation, let's go ahead and merge these data sets. All right, so now we're going to go ahead and merge this data. Now, one of the things that you might end up doing is creating a function like this. This function itself is essentially doing what we did up here, right? So df ilog 0 is getting the row at index 0. And this function itself, it has a row coming in so that we can actually do something like df.apply and using this function for each row and doing access equals to 1. Right? And so what's going to happen is it's going to create that column for me with this adjusted salary too, based off of a number of things related what we see here. And of course, it's actually getting the multiplier from the data frame itself, which is okay. But this actually might end up taking a really long time if it even works, which in some cases it will certainly work, right? But again, it's going to take like 20 to 30 seconds to run this entire calculation. But then if I actually needed to change the multiplier or something like that, I'm going to have some issues, or even add the multiplier. But at the very least, it does give me an adjusted salary there. It is off a little bit because of the multiplier that I'm using, but nevertheless, it's definitely there. Okay, so now I'm going to go ahead and change it just slightly. Okay, so let's get rid of that df apply. And now we'll go ahead and actually use the built-in merge method, which would allow me to run this. Okay, so the merge method would be taking our inflation data frame. I want to actually reset the index here. And I'm going to go ahead and say in_place equals to true and drop being false. What this will do is put my index value being 1, 2, 3 again and keep my date column. Right? So I run that again. And now I have the df. I can just look at the columns again, and I should be able to actually see my date column. This, of course, resetting this index will mean that this portion does not work any longer either. But there we go. Okay, so now I'm going to go ahead and just run the DataFrame.merge. Okay, so whichever data frame I want to merge with, this is going to be the resulting data frame, right? It's going to be going off of that. I'm going to grab the other one that I want to merge it with. Then I want to say which column, so left on. So if I want to do it on year start, and then right on date. So date is one of the columns on inflation, so that's the right part. Left is here. It's also happened to be, this is on the left side, this is on the right side. Thus, this is what it's going to attempt to merge on. Now in this case, we're going to have a value error that I'm trying to merge on int64 and object columns. So what is happening here? Well, if we actually take a look at each one of these things I'm trying to merge with, we see df year start, .dtype, and then inflation df, and date, .dtype. We will get two incompatible data types. Right? They're just simply not the correct data types. One is going to be an object, one is going to be an integer. Okay. Now, I want to make sure that they are the same so I can actually merge them. But I'm just going to change it a little bit. So I'll go ahead and say df date equals to df.yearStart.apply lambda x, and I want to actually import date and time. So I'm going to go ahead and bring all the way up here and bring in the import for date and time. Run that cell. And then lambda x is going to be simply datetime.datetime and strptime of the string of x. This is, of course, coming from lambda. and then we'll put it into the format of, %y, capital Y, %m, and %d. So it's 4-year date, 2-digit month, 2-digit day. Okay. And so what we actually have here is I should be doing -12-31. Now the reason I'm doing 12-31 here is because year start is, of course, the year itself, right? But I actually need it in the same format as my inflation one. So I'll go ahead and copy this. And then I'm going to go ahead and update the same thing roughly with my inflation data frame. This time I'm just going to modify the original date column. And this time I don't need -1231 because it should be already in that format. And so once I run that, I should now be able to run these D types here again. Of course, this is one of the advantages of not having it in order. And we can change this to date as well. And those data types should be the same. And sure enough, they are. So now what I can do is I can run df.merge with the inflation data frame left on, now that I have that date column right there, and then right on, and again, the date column as well, and run that. And this should return a data frame here. And we know that it's actually a new data frame for several reasons. One of them is all this. But the fact that we don't modify the original data frame by default, we get a new data frame. So I'm going to call this merged df. Okay, and we run that. And then I've got my merged df.head. Okay, and then what I can do is say merge df adjusted salary audit. And this is going to be merge df of the salary, and then times the merge df of what? Well, if we look at the head here, we've got our salary, our adjusted salary. We have the date object in there. This is what it was actually merged on. We have an inflation rate based off of that date. Notice that all of the users, or all of the players, actually, I keep saying users, but all the players here have the same start date here with the same inflation rate. So now all of those users have that inflation rate. And the other part that's good about this is if I do find the correct inflation rate, or if I ever need to change it, it will actually be in this merge data frame now. And then I also have this multiplier, right? So that's the actual column that I want to use. So to find the adjusted salary, getting the original salary times it by the multiplier. And this will actually give me that data. So the merge df.head, this should actually show me this now adjusted salary audit. And from here, we could get the differences between it. We can get the sum. We can do all of the analysis that I was doing before, but now we can actually see that merged data, right? So that's actually, I think, pretty cool how we actually go about merging things. So the key things here on doing the actual merging, the biggest one is the actual data type being the same, right? So the reason I actually turned all of these into datetime objects is so it'd be the same. They all could have been integers as well. I could have just had the year and it still would have been able to merge. But of course, the date itself is something that we've been working off of, so we might as well use that and actually as a datetime object, right? And the datetime object we actually merged on is this one right here, which I think is pretty cool. So this actually gives me a much more appropriate look at what the data set should end up being. Now, from here, I would actually want to determine what the actual difference is between this data, right? So the adjusted audit data and the adjusted salary. I think it's actually going to be significant. In fact, I know it's significant. And you could go dive deeper into that with the course notebook itself for this one in the merge datasets portion. That will actually show you how to dive a little bit deeper in here. But at this point, we've actually covered this quite a bit as to seeing how to actually merge our data sets, but then also how to do the different math to find what the major delta differences are. So in other words, we could actually go take this merged data set, this merged data frame, and say delta, and this would be our merged data frame adjusted salary, and then minus our merged data frame of the actual audit column. Like that. And then we can actually combine all that with merged df and then delta dot sum. Right, so this would give me exactly how much is missing, right, of that entire data. And it's going to be significant for sure, right? So it's off by $400 million. That's a lot. It is a lot if we see that our adjusted salary, let's see what that is, because the actual salary itself might be in the billions, if not potentially even trillions of value, right? And so to look at this one, let's actually do some string substitution in here for that one. And do comma, period, 2F, just so we can see the data a little bit better. And this is a lot of money, right? The delta now doesn't look nearly as big. It certainly still is big, but it's definitely not nearly as big. And so again, we can see what the difference between these two are by either taking the adjusted salary sum minus this sum or getting the audit sum itself, right? And so we run this again, and now I can actually see what the actual difference is between these two. It's still at the 68 billion mark, right? It's not actually that much different from what we saw before. It is up a lot, but it isn't a crazy amount. So yeah, I think a lot of things about this are pretty good overall, but this will require me to actually do additional analysis on whether or not my merged, data frame is accurate. Now, that's not the point of this. The point of this was to see how to actually merge this data in a reasonable manner, and then to, sort of test the assumption that the data we have is coming through is accurate. All right, so now we're going to implement a third-party REST API service to extract or enrich our data sets. Now, this isn't the only way to extract data. You can also use a technique called web scraping. Now, web scraping itself typically goes and opens up a web page of some kind and then grabs this data that's typically displayed for a user. The difference between that and an API is the API itself is already structured and formatted in a way for our software to use it. So that's essentially what an API is. It allows software to communicate with other software for some means. In many cases, that means to grab some sort of data. Now, in our case, we're going to be using the Ball Don't Lie API because it's free and it doesn't require you to sign up at all. It's really, really good. Now, the NBA or NBA.com actually does have an API. It's just not necessarily public and it's not necessarily well documented. I did use the NBA API client. This is a Python client that seems to work really well, but it actually fell apart for me. You can actually go through the appendix itself. I do have a few items in here on the official repo for this series, but I actually did try to use this NBA API, but it just was falling apart, which gave us a really good opportunity to discuss how to use API services in general. That's essentially what we're going to be doing here, is using general techniques for API services, because that's what Ball Don't Lie does. It's a really solid REST API to grab some data. So with that in mind, let's go ahead and get started. So it's, of course, balldon'tlie.io, and we're going to be using this HTTP request. Now, if this service goes down or anything like that, please let me know so we can update the notebook at least. But the general idea is we're going to grab all the players to really get the IDs of these players on this service. This ID is unique to this service as far as I know. And then the next thing, after we get those IDs, we're going to get stats for these players, because what it says in one of the parameters, don't worry, we'll go over this again, is we can actually get stats for an array of player IDs. So that's what we're going to be doing. It's just using those two endpoints to get stats about any given player. And heck, we might as well start with good old Michael Jordan. Okay, so going back into our notebook here, I have these two endpoints here, right? So the players endpoint and the stats endpoint. Again, those are coming directly from the API itself. This is very common. They'll give you some sort of endpoint and parameters to request with that endpoint. So the first thing I want to do is actually get the players endpoint, like this actual data. So I'm going to go ahead and look this up using Python requests. So we'll just do a simple requests, or rather R equals to requests.get, and this players endpoint. Okay. And the reason I know it's .get versus any other HTTP method is because HTTP requests has get and that URL, right? So the best APIs really document this well. If it was a post method here, if it said post instead of get, we would just change this to post. But of course it says get, so we'll stick with that. And what it also tells us in the API is that the above command returns JSON structured like this. Okay, so curl is a way to write this on our actual terminal, right? So back into Deepnote, I can open up a terminal and create one. Let's just do one real quick. I'll break this down really fast. And so this does take a moment to actually boot up. But now we're in the actual terminal itself. I can paste in curl here, run it. This will actually run the command. Looks like it's not being formatted correctly with my screen right now, but we could also run this in our notebook too. So that's also a possibility. And while you're learning how to work with APIs, it's definitely a good idea to just go off of the examples that they have in the documentation. But I'm going to go ahead and really build this into what we need to do, which is get this data and then turn it into a Pandas data frame so we can do additional analysis. So I'm going to go ahead and do request .get of this URL. Let's make sure that everything is imported and ran. Okay, and so one of the things that you always want to check really is the status code. Basically, you want this code to be between 200 and 299. That is a successful status code. If it's not between those numbers, you can actually go to the API. In this case, in many cases, this is what the actual error codes end up being. But this will actually show you the error codes that happen. So if you're asking for too many requests, you'll get this 429 error, as it says right there. But anyways, so now that we've got the status code, let's actually take a look at the data with r.json. Again, I remembered that the response will be JSON data, which is how I know that I can run r.json. And what this ends up being is an actual dictionary. This turns it into a Python dictionary. So no longer JSON, now a Python dic. Okay. And so what I see here is a bunch of data in here. So I'm going to go ahead and say JSON data equals to that. And then since it is a Python dictionary, I'm going to do JSON data.dict, or rather .keys, and see the keys that are in here, right? So let's go ahead and run both of these items. And the reason I have these keys is so I can look at, well, I know that the data is probably the player data, right? So going back into our API here, we see that it actually does lay it out for us. This is our player data. This is the actual data that I want, but I also have this metadata here, right? So it gives me total pages and the items per page. Now, of course, if I was actually reading into this, I see that the page number is used for pagination. Pagination means that it's not going to just send you back all of their data all at once. Instead, it's going to require you to make additional requests for that data. So to actually understand this, we can actually look at the metadata. So it's in the JSON data of meta, right? So again, I got the keys here. I just used one of those keys, and we can take a look at this metadata. All right, so I've got total pages 150. There's 25 per page. Okay, so I wonder if I can actually lower this number down, as in the number of total pages, by raising per pages or per page. Right, so this is actually a possibility. looking in the documentation, we see the page number. This is what number you want to use for pagination, which we'll talk about in a moment. We also see this argument for per page. That's what these query parameters are. So what I can do is I can increase this number, and the maximum is 100. So the slight change when you see some sort of query parameter, you usually put a Q here, the parameter name itself, so per page, and then I'm going to put 100, right? So that's actually how we would update and change this, right? And verifying the actual parameter is this right here. So whatever that ends up being, you can copy that and paste it in here after the question mark. And we can also add an ampersand with page 0. The ampersand is how you can actually append additional query parameters on here. Okay, so now that we've got that, let's go ahead and run this again. And we should actually see roughly the same data, but now our total number of pages has gone down to 38, and the page count is now showing 100. Okay, so the total count of items is 3,739. So that's the amount of players that this data set has. I have no idea if that's accurate or not. That's not really the point. But what we're going to do is now we're going to iterate through all of these things. Right? We're actually going to get every single data point that's in here. So what I want to do is just say data set equals to this. I'm also going to do the total pages being the metadata.get and total pages. Okay. So now that's going to be a number. I can do for the actual page number in range 0 to total pages plus 1. Now this should be an integer itself, so I'm going to just go ahead and make sure that it is an integer here. But as I see on here, it says total pages. That is definitely a number. But anyways, I want to make sure that it is. Now with the range, we actually just need to add one more to ensure that we are including that final page. And so I can print out whatever that page number is, of course. So I run that, and there we go. We've got 38 at the end, and we also have 0 here. So we actually might be duplicating the values here, because page 1 and page 0 might be the exact same page. I don't know that for sure, so I'll just go ahead and grab all of that data. Now, what I need to do here is I'm going to grab this player's endpoint, and I want to update it. Okay, so I've got my player's endpoint. Let's just call this a URL now, and I'll go ahead and say base URL, and that's going to be essentially everything right here, and except for the query parameters. So I'm going to change this to being the base URL, and we'll put F in here. Okay, so notice that I have this page number here. Well, now I can actually use it with the iteration argument value here. Typically, I don't actually name that when I'm iterating through numbers. I actually put X in here. So I'm going to go ahead and put X there as well. Okay, so this is our new URL. This is the new endpoint that I want to look up. So what that means is I'm going to go ahead and do requests again. So requests.get of this URL. And heck, we could even print out this URL to ensure it's correct, right? To ensure that our page number is actually changing for each iteration. Then I'm going to go ahead and say if not r.status code in range 200 to 299, I'm going to go ahead and print out skipping and just run continue. This, of course, will jump the loop. It'll go to the next page in this loop. And then after that, I'm actually going to get the data, or rather the JSON data. The actual response data is r.json. Then the actual data is inside of r.json. And then the key of data. We actually saw this key up here when we did JSON data keys. There's our data. And so I'm going to go ahead and add this to our data set here. Now, oftentimes you'll want to say, oh, dataset.append that data. But what this data actually is, based off of my test that I did prior and also their documentation, it actually shows a list here, right? So those brackets is showing a array in JSON, which is a list in Python. And so we actually can, instead of appending this data set, we'll do dataset plus data, or plus equals, or dataset plus data, right? Yeah. Okay. And then finally, I'll go ahead and run this. Okay, so it's showing me all of those pages. It's actually working pretty fast. And then we'll go ahead and look at the length of our data set here and run that. And I'm getting 0 because that should have been plus equals to data. Okay, and so after that runs again, I've got 200 or 2100. Looks like it skipped some. I'm guessing probably because I've made too many requests in a short amount of time. So I want to actually implement one other part of this, and I'm going to go to the top and I'm going to import time. And we just want to sleep a little bit between requests. So before each request, we'll just do time.sleep, and I'll do 1 second. That way we're not bombarding their service at all. It's actually going at a little bit slower of a rate for our requests. And so now every second it's going to grab something new, which of course in this case is going to take about 38 seconds. So perhaps 1 second is maybe too high. Maybe we can do, 0.25 seconds. At least it's not almost instantaneously. That way it's not skipping any of these URLs, and we're being a good citizen of the REST API. Now, the reason I also know this is because of, well, it's going to give you a rate limit of 60 requests per minute. So that's 1 per second, right? If you are doing 60 in that time. I almost did that. I had a little error. I had to do it again. And thus it actually did limit my requests. Not surprising at all, which is why I actually added that time in just to make sure that I'm not overloading it. Well, now my data set has 38, 39, and what we saw before was 37, 39. So it's clear that I have an extra 100 on here. So the very first page was probably scraped twice. We'll deal with that in a moment with pandas. So I'm now going to go ahead and say DataFrame equals to pd.DataFrame of this data set. And then I'll go ahead and do df.head and hit enter. And there we go. So we now have all of this data. So one of the things about this data that I know for sure is that I have duplicates in here. So what I'm going to do then is I'm going to run DataFrame dot drop underscore duplicates. Now I can actually declare a subset of data, like where do you want to drop the duplicates? In this case, I want to drop it based off of the ID. The vast majority of services have a ID that is associated to that data of some kind. So the ID is typically unique. Now this isn't always the case, but I think it's fair to assume that any given player's ID is going to be unique, right? It's kind of like your ID at work or your government issued ID. That's most likely going to be unique to you as well, or at least we hope so. So in this case, I'm going to go ahead and just drop those duplicates based off of that ID. Actually, before I do, I want to go ahead and do df.shape. I want to see how big it is right now. It's the exact same as the length that I saw earlier. Now I'm going to go ahead and drop these duplicates. And I also want to do in place being true. So we'll go ahead and run that. It drops all the duplicates in the current data frame. And then now we can look at the shape. And now what do you know? It's 100 less. So that is definitely something that we'll want to do from time to time. Now, I didn't have to do that because a lot of this will still work really well, but it is something that I wanted. Okay. And so there's also a lot of NaN, as in not a number, values in here. And so I actually don't want everything in here. I really just want their first name, their last name, and their ID. Because this player's, statistics, the player list here is only meant to be for our player statistic, each individual player, because again, I just needed that ID. So my final actual player's data frame will be this initial one, but only certain columns. So ID, first name, and let's say like last name. Okay, and so we'll go ahead and look at that with playersdf.head. Okay, so what I want to do now is I want to just take a look at the other API, the actual statistics API for any given player. So I'm going to go ahead and initially just start off with a random player itself. So any of these random players. So I can use .sample and I can give a number of sample items in here. What sample will do is just return a random row for you, which is pretty cool. So with that, I can actually use the ID and do .item, and that will give me a random ID from my player's data frame. And so there we go. We've got a random player ID there. Okay, so we will definitely adjust this later to being a specific person's name, but for now we'll just use this random player ID, because the next part is actually using our stats API. Okay, so let's bring this all the way down and paste it here. Now going back into the Ball Don't Lie API service, I'm going to jump into stats, and I see that I can combine query set parameters, for example. So what it's giving me right here is a good example of how to do their query set parameters. Okay, so going back into here, I'm just going to append that to the end here and sort of break it down. So let's go ahead and look. All right, so we've got seasons. That's 2018 to, well, and also 2015, not in any particular order. It's got player IDs. This is 2 different players, it looks like. Notice that it's being strung together with the ampersand there. And then finally, whether or not it's a post-season statistic. Okay, so how do I actually implement this with our player here? Well, this is going to be the base URL first. Again, we'll go ahead and do that. So our new base URL is going to be the statistics here. And then our stats endpoint, or really our URL here, is going to be based off of this base URL. Seasons, I am not going to worry about. I'm going to get rid of that. I'm going to get player IDs. I only really want to have one of them, so I'm going to get rid of the other one. And this is what I'm left with. Player IDs. It is going to be an array, which is why that bracket is there. I'm going to go ahead and add in my random player ID. And postseason, the next thing here, I'm going to go ahead and say false. There's going to be 2 different kinds of statistics here. One is going to be a postseason statistic. The other is not. We'll implement that later. But for now, let's go ahead and take a look at our URL. It's pretty straightforward, right? It's going off of our player ID, and there we go. The only thing that might trip you up is this brackets. Just keep in mind that when you need another player, if you did, you would just go ahead and add them in here and do something like that. I'll just go ahead and add a +1 here. And now you have actually 2 players in there. But of course, I don't want to do that. I just want to mention how it would be done. Okay, cool. So now I've got this URL. Again, I'll go ahead and do requests.get URL, because again, the API itself is a get method. And again, it has a lot of query parameters, the per page, the actual page number, all of that stuff, right? So yet again, I can say per page 100 and page being 0, right? So we're already starting to work towards the type of pagination we just did, the exact same type. So if I do r.json, I should actually see all of the statistics related to this particular user. And if I look at the metadata, just like I did before, I should see all of that metadata for that particular user. In this case, it's less pages, right? Because it actually makes sense. Given any given player, they're going to have different number of stats. They're going to have a lot or not very many. In this case, this user has 162 stats for the regular season, which I would assume that means 162 games in that statistic, right? Because we can actually see that with looking at one of the data points in here of what one of those statistics looks like. And here it is. So if you know basketball well, you kind of know how to break down these statistics, like BLK stands for block, FGA stands for field goal attempt or a shot attempt, FGM stands for field goal made or a shot made, and so on, right? It also has information about a game and all that. So in the next one, what we want to do is actually start to unpack this quite a bit to actually turn it into a proper notebook itself, right? So this right here was meant to experiment with that API. The next one is going to move beyond that experimentation and turn it into a little bit more reusable piece of all of this. All right, so now we're going to go ahead and continue where we left off with the extracting data from the Ball Don't Lie API. And so what I want to do here is I want to implement a method for extracting each data set, right? So I've got this data set right here. That is an entire function for extracting it, right? So all I'm going to do here is define, get players data set. And that's it. Now, I could add in a bunch of arguments here, but I just want to make one really simple function to do this, and then I'll return this data set. Okay, and so one of the things here is I see that I have metadata already in this get players data set, which actually means that I want to bring this in here as well. Okay, and so I'm going to go ahead and actually grab the request for the base URL, and then I want to grab in the JSON data for it. And then I want to grab the metadata, which is JSON data.get, or rather just metadata. And really, if the request is, or the r.status code, if it's not in a certain range, so if not in range 200 to 299, I'm just going to return an empty data set or an empty list. At the very end, I'll return that actual data set. Now, of course, the reason for this is just to implement everything faster. So I'm going to go ahead and select all these and start deleting them. I don't want to have redundant code here. And the only reason to show you that was really to explain the thinking behind this function right here. So now that we have this, I'm going to go ahead and get rid of print statements here. I no longer need that. I could add in the argument for this as like maybe the per page number. And in my case, I used 100. So I could totally turn that into an argument itself in here. And also, I would probably want to do the per page in here as well. So this is not the correct base URL. Let's just update that a little bit and change this one to being a init URL, because it's really just our initial URL to get that initial data for really the next or the total number of pages, right? So there we go. That's a little bit better. So we've got our base URL that is used twice in the init URL and then in each page itself. Cool. So now that we have this function, I can say my players data set equals to, we're going to go ahead and get the players data set and just run it with the actual page number itself. And it looks like I get an error. That's because I didn't put an F string in here. We definitely need that string substitution. Let's try that again. And I got a key error for metadata. Of course, because it should be meta, I should actually have followed along with what I did before, but now I've got this players data set, and so I can actually do the player data frame, being this players data set with the IDs dropped, the duplicate IDs dropped. And something I did have down here was actually copied all that and used specific columns. I can still do that, right? I can still use specific columns just like this. And so now there is our player data frame. Okay. And so I'll go ahead and delete some of these other items in here. Cool. Simple enough. Let's go ahead and run our player data frame here from that data set. And if I scroll up a bit, we've got it. Okay. So now with our player ID, I didn't implement this one, but I can with, well, pretty much copying this exact same function. Now I will say if I was starting to do this in production, I would make a way to not repeat myself, as in to have one function that does all the requesting, the pagination requests, but that's something that's a nice little challenge for you itself. So in this case, I'll go ahead and call this get stats. Okay, so the actual endpoint itself, let's go ahead and comment these things out for a moment. The actual endpoint is this right here. So same exact one, right? The one thing that is missing in that is going to be our player ID, which is something I want to actually pass in to this argument. So we'll go ahead and do player ID equals to, let's just say 1. Okay. Maybe we'll have to find Michael Jordan's player ID and have that as the default. So now my base URL is going to include that player ID. So whatever that is, it's going to include that. And then my other URLs will just need a ampersand next to it. That's it. That's the only real change to those URLs. Okay. The player ID is in there now, and then all that. But there is maybe one other change that I want to add, and that is whether or not I want this to be a postseason game, right? So we saw this argument right here. So what I'm going to do is add that in as well. And this time I'm going to call this postseason being false, the actual Boolean value for postseason. So that means the actual argument in our base URL is going to have to be based off of that. So postseason equaling to false. Now I'm going to go ahead and say the postseason URL, or actually param, is equal to this. So it's either going to be the string of true if postseason, otherwise it'll be the string of false, right? So if the argument that's coming into the function is true, then it'll be true, otherwise it'll be false. Okay, and so now we use this postseason param right there. Okay, not really that complicated as to what's going on. Hopefully not, at least. So now let's actually implement this. Let's give it a shot. Okay, so we've got our get stats here, and I'll go ahead and do regular season stats equals to get stats of our player ID, which I should still have. Let's see right here. There's our player ID. I no longer need this or this. Okay, and then I want to make sure that postseason is false, right? And then we will do our postseason stats. And this time postseason is true. Okay, still has a little bit of a sleep function in there, so I'm going to go ahead and run these. This will take a little bit of time, maybe not that much time depending on the user, right, or the actual player. So if I run the length of this, we've got 262 regular season stats, and then the postseason, we have none, okay? So for this user, that's what's going on. Okay, great. So now that I've got that, let's actually turn those two things into a data frame. So regular season and df equals to, let's go ahead and do just PD and data frame. I'm not going to do the postseason one yet because I want to take a look at the regular season here. Okay, so we run that. There's our regular season. Now I might need to drop the ID again. That's definitely something I'll probably end up doing. But the idea here is if I scroll over a bit, I see that there's a game here, which looks to be a dictionary. We'll look at that in a moment. And then we've got a player in here, also a dictionary. And then we've got a team in here, also a dictionary. Now, a lot of these things I could have done on my player data frame as well, the one from above, but those don't actually, that's not the data I'm actually looking for. The data I'm looking for was the stats here, these statistics for any given user. And so now what I want to do is grab one of these rows to take a look at, let's say, the game object. Okay, so I'm going to grab one of these rows with .ilog, and we can use 0. I could have used sample as well. It could be either one. But I'll use ilog of 0. Oops, I should use brackets here, not parentheses. And so here's that first row here, and we've got a game. So I'm going to go ahead and take a look at that game just to get an idea of what's going on here. So it's a dictionary itself. It's not multi-layered. It's just one dictionary. There's only key value pairs, as in there's not another dictionary nested inside of here. So it's really just one nested dictionary. So what I can do is I can actually unpack this nested dictionary, or I can unpack each one, right? And I can actually change it for the entire data set. So what do I mean by this? Well, if I define a function called unpack nested dictionary for a row, right? So for the row, we're going to unpack a nested dictionary. What are the columns that I want to look at here? Well, I said game, team, and I believe I said player. Let's look again. Up here, we've got game, player, and team. Okay, so these are the dictionary values that I want to unpack. So the idea here is then say for call and calls, we'll go ahead and say column value is equal to the row of whatever that column is, right? So this is equivalent to saying like row game, for example, right? And that will give me the value, which this should be a dictionary, which I'll say if is instance the actual column value of a dictionary. Then we'll go ahead and unpack it and apply it to our row just slightly different. So I'm going to go ahead and say new column name is equal to, well, what is it that I want to make it equal to? I want to make it equal to the keys that are in any given dictionary, right? So what I'm trying to say here is I want to have it as game ID, game period, and so on. And then game status, right? So all of these things in here just append game underscore in front of them. Now, I am not positive this will work all of the time. In fact, it probably won't. But in this data set, it works fine. I don't have anything else with game starting in front of it. Player, I don't have anything else with player starting in front of it. Team, I have nothing else with team starting in front of it. So that's why I know I can actually unpack this in this way. So to actually generate this for the row itself, what I have to do is I have to do for key and value in the column value, the column dictionary, and dot items, right? So this is iterating through that key value pair of a dictionary. And so now I'll go ahead and say new column value, or new column key rather, is going to be equal to the original column name, which is this up here, and then underscore the key name. Okay, and so now I'll go ahead and do row, this new column key equals to this value. Okay, and so again, this is what the new column keys will look like, roughly speaking, for each one of these columns. And so I'm now going to go ahead and return that row. Okay, and so I want to apply this to my data frame. So now I'll go ahead and grab my regular season data frame. And we'll go ahead and do regular season data frame dot apply this unpack nested dictionary on axis being 1, and then we'll look at this regular season data frame head. Okay, so really just trying to flatten out this data. This is just a quick and easy way, maybe not the quickest way, but a quick way to do that. Now, I would absolutely love to see a more efficient method to this. There probably is one, and it's probably based in pandas, not necessarily going through each row and unpacking it in this way. But once I do unpack it, as we see here, now I can see that I've got my game is still there, my player is still there, team still there. But if I scroll to the end of this, we've got the game ID now, the game date, game home team ID, and so on, right? So it's pretty cool. It's now unpacked quite a bit more, and it's going to be a lot easier to analyze this flat data in this actual data set. Great. And so that, of course, is not it, right? So there's definitely other things that I'm going to want to do to this data frame. The next thing would be, after it is unpacked, I want to change this game date, and I want to add a year column in here. Like, what year did this actually occur on, right? Now, this is actually also not that challenging to do. So the first thing I need to do is actually update it to having a year. Okay, so what I want to do now is inside of this, I'm now going to add a new condition saying if game date in the columns here, then I'm going to go ahead and say df date. I'm assuming that the date is also not in here. It's not. Is equal to pd.toDateTime of the, or this should be not df, but rather regular season df. It's going to be going off of that game date. Look at that method right there. That's pretty cool, right? And so I'm actually going to cut this out from here so I don't have to reapply everything, but rather just see this one single date. And we'll run that. And so if I scroll all the way to the end, because that's where it's going to add that column, it's going to append it to the end, I now see that it's a DateTime object based off of that date, which is really cool. So once I do that, of course, I can actually take that data and say year and say the regular date, regular season data frame date, then I can apply lambda x and just return x.year. And so now I run that and I scroll all the way over to the right again, and there's our year. Okay, so of course this is going towards the salary itself. So eventually I'm going to aggregate all of this data to have it in the salary itself. So I can use the year, not necessarily the date, but really just the year to aggregate all this data. This year, how many points did they score on average, for example, and then what was their salary for that year, okay? I could do a lot more things than just that, but once you actually know how to do what I just said, then you'll be able to add any other statistics that you might want to have, including the number of games played in that year. Okay, so now that we've got this, there might be one more thing on here, and that is based off of what I believe is the minutes, okay? So I thought this was kind of interesting, is there's the minutes, but it's in a string where it's 13 minutes and 42 seconds. At least that's what it appears to be for me. So what I want to do now is define a method called getSecondsPlayed. Okay, and so this is going to take in a value, not a row this time. And I want to just have a default of h as in hour, minute as in minute, or m as in minute, s as in seconds, and set it equal to 000, and just return a date time object here. So time delta of the hours being h, minutes being m, and seconds being s, and then doing total seconds here. Okay, and so I need to import date and time if I haven't already. Looks like I have. Okay, so let's go back to the bottom. And so I'm going to, of course, actually make this function work. But before I do, let's go ahead and add this into our data frame itself. So very similar to like the game date here. I want to look for that column of min, which stands for minutes. Now what I want to do is say seconds based off of the minutes. I'm going to go ahead and get rid of this. And so it's going to be just like this, but now the minutes itself. And then we're going to go ahead and run .apply and gets seconds played. Now the reason for that is one more condition on whether or not they did play. So did play, and this is going to be based off of this seasons here, or the seconds rather. And then we do .apply and lambda x. Basically x is greater than 0. Okay, so right now it's going to be 0, for sure 0. But in the future, once we actually get this get played thing working, we should actually see a couple new columns in here. So if I scroll all the way over, what I see now is seconds and did play being false. There's no way that's accurate because this is data that's based off of this particular user. Now, it's also certainly possible that this will always be true if there's even a data point to it, but I don't know that. And the documentation doesn't say that. So I wanted to parse this data out based off of what I'm assuming that min means, like as in minutes, right? I think it stands to reason that that's what it would mean. But now let's go ahead and actually break this down. Now, to verify that it is minutes, we could probably go to the NBA.com, take a look at any given game, and find out how many minutes that player played. That is definitely steps that you'd probably want to take to further validate this data. But I'm going to assume that that's true, that it is the actual data. So now what I want to do is say if there is a value, I want to split that up into a time string. Okay, so value.split of the colon here, right? So looking back at the actual minutes themselves, that's what it looks like. Okay, so what I'm trying to do is split this up into, there might be an hour time in front of it. So right now it's just minutes and seconds. So I just wanted to split that up and really say if the length of the time string is equal to 2, then I'm going to assume that it's just like this one, which is minutes first and then seconds second. So I'll go ahead and say ms is equal to that new split. And then if it's equal to 3, then I'll put the h in there. And if it's equal to 1, You could assume that it's seconds, but they're probably not going to put seconds as one single item in a minutes column, right? It would probably be always based off of minutes. So in that case, I'll go ahead and leave it in as minutes. And that's really it, right? So actually, I should probably tab these things in here, but that's probably it. Now, one of the other things is maybe I need to for sure make sure that all of these are actually digits. So now I'm going to go ahead and just take this one step further and say if the string of h, for example, is a digit, then I'm going to go ahead and say h equals to the int of h, right? Just to convert the actual data type into what it should be for each one of these. And it actually should be a data type of, digit with that. But we just want to make sure. Okay, so there we go. So we got hours, minutes, and seconds. So now we run this all over again. And if I scroll to the very end here, we should get our total seconds based off of the time delta, total seconds, and then whether or not it was did play. Right? Of course, we could convert that back into minutes if we needed to, but I just wanted to make sure I'm really going after this Boolean of did play. So having seconds, anything more than 0 means that they played. And if it is 0, if a lot of them are 0, then I probably did something wrong in here, right? And that's actually what I did when I was testing this, right? I made a lot of assumptions about that data and I did it incorrectly. I didn't want to go through that with you, but now we understand exactly how to get essentially what I'm trying to do. So my goal with this actual video was to really show you how to implement all of this stuff. So what I'll leave you with is the fact that, hey, how do we actually make this data frame even better, right? How would I actually change this to being, one call, very similar to what we almost did with our player data frame, right? So the player data frame, we get that data set and then we have this right here. That's only a few steps. It doesn't really need that much more configuration, right? But our actual regular season data frame or our post-season data frame, we absolutely need to update it a little bit. And that's something we'll definitely do in the next part, but I want you to stop for a moment and figure out in your mind, how do we actually make this a much more seamless way to grab either season, whether it's regular or post-season. How do we grab that data frame in a little bit better manner? And then also thinking about, do we still need these dictionary values? So I'll leave that in your mind for now, and then we'll pick it up in just a moment. All right, so picking up from where we left off, we need to create a function that will generate our data frame for us and do all of the cleaning for us. So what I'm going to do here is define it as get stats df, and then take in a stats data set, right? That, of course, is going to be one of these data set items here. I'll tab this in and just pass that. This time I'm going to just declare it as df, and then we're going to return that data frame, okay? So one of the things I want to do right off the bat is I want to make sure that I run the drop duplicates, and I want to get the subset being ID, right? And I also want this to be in place being true, right? That is for sure something I want to do. I do not want to have duplicate statistic IDs here, okay? And so there's our first step. Now I'm going to go ahead and run this one. What's the next step? Well, we need to actually apply this unpacked nested dictionary here. And so I'm going to go ahead and put this function above my get stats data frame, and then I'll go ahead and apply it like what I did here. Now in this case, I'm actually going to apply it right above my drop duplicates. I'm actually going to use the drop duplicates probably last, okay? Because I may or may not want to never do that. Maybe I want to always keep the duplicates in there to improve my REST API calls later, right? So having duplicates would mean that I'm getting the data incorrectly. And so perhaps I would want to remove that piece later, which is why I'm leaving it last. Okay, so now we have unpacked the actual nested dictionary. Notice the actual columns I'm using again in here. So you would potentially be able to update these columns in here. So that would be another thing that you could add as a larger default variable as in, my nested stats columns, something along those lines, and actually just using that as our iterator. So that if you ever need to change those again, you could change them. You could take one out or you can add one in. Okay. And so these nested columns, after we actually apply it, I actually want to drop those columns themselves, right? So to do that, we use df.drop. This is how you drop columns. You just run .drop and then the column names themselves. And just like many things, we want to run in place being true. So we unpack them, then we drop them. Pretty simple, right? Cool. So now let's go ahead and scroll down a little bit. I'm going to get rid of that right there. And I don't want this head block in here anymore. So run that and get rid of it. And then here's another thing that I do want to have. So let's go ahead and cut it out. And I can put it above or below the apply. That part actually doesn't matter. The organization of this should not matter because of the column itself. Now, of course, the data frame name does matter. So we need to use df instead of the regular season df, right? So there we go. And I add this condition of if it is in those columns, that means that, hey, actually, we do need to have it in a particular order. It needs to happen after the unpacking occurs because of the game date itself. If it happened before, then we would have additional work to do to actually get this data in here, right? I no longer need that head call, so I can get rid of that. And let's go ahead and scroll down a bit and see what the next thing is. We've got this get seconds played function. So I'm gonna go ahead and cut this and paste this right underneath my nested dictionary unpacking. Okay, straightforward function, hopefully. It probably could be cleaned up, but we'll leave it in. Next, of course, is the minutes part. And that's probably it. That's probably all I really need to really use an effective method for extracting our data for any given season. Okay, so I'm going to just change these to df all around. There we go. And so now we've got our stats data frame. And so we can do our regular season df being get stats df of that data set. Right? And then just copy this basically exactly for our post-season stats. And now we have two different data frames in here working. Now, what I actually want to do, since I just refactor this notebook a ton, I need to make sure that I'm actually running this correctly, right? And so what I've got right here is this is not found in these accesses. So perhaps there's something with this that may or may not have occurred correctly, right? So with the columns themselves, they're not showing up inside of dropping the postseason. Okay, so let's go ahead and get rid of that. And we've got the regular season should hopefully work. And then we'll run that postseason one as well. Now, I actually have the sneaking suspicion that the postseason stats themselves, well, don't have any stats. So the idea here then is if the length of the stats data set is equal to 0, then we're going to return just pd.dataframe. So an empty data frame. Okay. And so now when we run this, we shouldn't actually get any real problem with the dropping because it's just going to be an empty data frame that's coming back from our postseason. Because not every player obviously plays in the postseason all the time or at all. So we do dataframe.head. Okay. And then that gives me a bunch of data. And hopefully with the game data dropped, looks like it is. And I do have the game ID. The actual flattened game data is there. The flattened player data is there. Flattened team data. All that stuff's data is there. And then our did play stuff. Everything's looking good with that one. And then with the other one, if we take a look at it, it's going to give us nothing, an empty column. Cool. So that's a little bit more of an efficient method to actually have our data being displayed. So that is pretty cool, I think. We can now extract the data from the API. From that extraction, we turn it into a data frame. Now with that data frame, we can actually start to analyze it a little bit more. And so that's definitely something that I'm going to want to do with merging this with our salary data as well. So that's something we'll do in the next part. If you have any questions on what we did here, let me know. At this point, I would challenge you to pause for a moment, think about everything we've done so far, and think about what we need to implement, which would be, I want to get the average points per year based off of the data frame, not necessarily the data that they're giving us, but there is the points value in here as well, which would be PTS. That's going to be the column for points. So I want to get the average for that for the entire year, right? And then what I also want to do is add to that the average for the entire year. I want to add the salary data there. I want to merge the salary data in. So take a moment, think about how you're going to do that, maybe even experiment on your own before you continue. All right, so I rearranged my notebook a little bit to make it a little bit more intuitive to how we use it in the future, which is grabbing our player ID first, grabbing the stats, and then creating the data frames. I got an unsupported type in part of this, and I actually realized what it was from. In our get seconds played here, we have a time string, and we actually split it up. This will always create a list. So I needed to, if the list element was a length of 1, I needed to actually get what that list element was. I didn't have that bracket before, and so that should actually solve that problem for some of my stats based off of a player. But the idea here is I actually don't want a random sample anymore. What I want is to be more specific about who I want to use. And so I'm going to go ahead and comment this one out, and we'll go ahead and create a new block here. And the name I want to grab is Michael Jordan. Okay, so how do I get Michael Jordan's player ID based off of the player data frame I have? Well, to do that, we're going to go ahead and say the player itself is from the players or the player data frame. And we want to pass in a condition here based off of an element that may or may not be in my player data frame right now. So let's go ahead and actually look at this player data frame. We've got first name and last name, but I don't have a full name in here. So that's actually pretty easy to do. We just come in and create it with full name being equal to the player df first name plus a space plus player df last name. Okay, and there we go. So this is probably not going to work for every person's name, and you can make edge cases for those, but it will work for a lot of them because there's not that many players. There's like 3,000, right? Maybe 4,000 in all of NBA history, at least according to this data set. So that's not very many players, as in there's probably a lot of unique names in here, maybe only a few that aren't unique. But Michael Jordan certainly is unique in the case of this player's data frame. So now that we have that, what I want to use is a condition. So the condition itself is going to be based off of another column. That column is, of course, the full name. And we want to set it equal to that name right there. And that's it. What this will give me back is a series of data that's related to that condition. So we run that, and there we go. Right, so what I could obviously do is I could do it based off of a couple conditions in here. Like I could have split this string up and made it first name and last name. But I'm just going to keep it nice and simple going based off of that. So what I want to do here is if this is not empty, let's actually see the type first. Let's just ensure what this actually returns. It does not return a series, but rather a data frame itself. It is a smaller data frame. So this actually is a cool way to slice down data as well based off of some condition. And like I said, there's many ways to have different kinds of conditions and definitely worth something looking into. So what I'm going to do now is I'll say player ID equals to 0. And we want to see if not player.empty. So when you do have a data frame of any kind and you want to see if it has values, you would not say if player, right? You would say if it's not empty. That's just a simple way to do that to see if the data frame is empty or not. And if it's not empty, then we can say the player ID is equal to this new player data frame, and we grab the ID in .item. And so now we should be able to print out the new player ID based off of my argument here. And so that's Michael Jordan's player ID in this REST API. So now I can do a quick lookup for him, get the stats and the data frame, and then just take a look at the actual regular season stats that do come in. This will take some time because of getting the stats of how long that might have to take. And also if for some reason we need to delay our lookups a little bit longer, then that is definitely something we can do as well. But that's all going to be dependent on whether or not when we are doing our lookups, if I see the skipping come up, right? So if the skipping comes up, then I'm going to want to update this time.sleep to being a little bit longer. But I think this should work just fine. I don't think I'm asking for that many things based off of this particular user. In fact, I think the stats are already showing that I didn't ask for that many things. So let's go ahead and actually take a look at how many games are in the regular season for this player or for Michael Jordan. In this case, it says 1,073. So we can look up how many games did Michael Jordan play, not how managed, but how many. Yeah. And so how many games? 1,072, right? So I have one more game on here. Not sure what that is. Perhaps it's a game that he just actually didn't play. But nevertheless, I now have this data frame with what seems to be his regular season games. And then also our postseason is going to be slightly different. It's going to probably be a lot less because that's the playoffs and all that. And now we can see how many postseason or playoff games did he play. And it's 179. Hey, what do you know? Interesting. Okay, so now we've got this data. Okay. And so what I want to do is actually analyze it a little bit more, right? So I want to get the average, so average points per year, right? So how do I actually get the average points per year on, let's say, for instance, our regular season data frame, okay? So if you remember back, we did parse in the year itself. So that means that I should be able to group this year. So I can do the regular season data frame, group by the year. We can get the points and then the mean. So that would give me the average points for any given year that any given player played or Michael Jordan played. Now we could of course verify these things with our actual NBA data. We go to NBA.com and check these things out. But I think these are pretty accurate. And of course, I'm actually calculating the mean. So there would be a way to calculate it based off of per game and then adding those things up too, like average per game and then add them up. But what this did was just going off of the group as to when the game actually occurred. So this actually might not be accurate to the season because of how NBA works. The NBA spans 2 seasons, right? So 84 and 85 are often the same season. I'm not going to worry about that at this point. I'm just going to go off of the year on how I actually calculated it, not so much the season. But you totally could. So the way you would actually figure that out is by taking the date that it occurred and then looking to see when the average season ends. So if the average season ends in the middle of the year, which I believe it does, you could then say, oh, if it happened earlier in the year, then it's part of the 2000 to 2001 season. If it happened later in the year, it's part of the 2001 to 2002 season, and so on. All right. Again, not going to worry about that at this point, but it's definitely something that we would want to do if we were going to make this better. Okay, cool. So now that I've got this data for the regular season, we can also look at the average points per year per postseason. We can look at that as well by grabbing the postseason data frame. This is not going to be really that shocking as to how this is going to look. I wouldn't be surprised if the average is a lot higher, and sure enough it is, because obviously it's Michael Jordan. Okay, so now we have 2 different data sets that we can work with. In fact, I want to enrich these data sets with this player's salary for that year. Now, in the case of Michael Jordan in particular, the salary is not necessarily going to be there for every single year. I've already tested this. It's definitely not, but that's okay. we could always make that data set better over time. All of these data sets could be improved if we found more sources to actually validate the data we are using. That, of course, is not the point of this series. The point of this series is to get our hands dirty with something practical. So what is it, the salary itself, right? How do we actually find that? Now, I think I had salary df initialized up above. And so I do, right? And lo and behold, the player is the full name. That, of course, was another reason to create that in our other player data frame, right? So this up here, we definitely wanted that full name for that reason as well. And so what I want to do is I want to find the salary data frame for our particular user. So now I'm going to go ahead and say player salary df equals to the salary data frame. I'm going to go ahead and copy it. I'm going to slice it down based off of the salary data frame itself for the player, equaling to the name that we had above. All right, so that's going to be our name up here. Of course, it's Michael Jordan. I'm going to get rid of some of these print statements so we don't have to see them. Okay, and so the columns that I want are adjusted, salary, and I'll also do year start. So in here, we'll go ahead and do adjusted and salary, and then year start. Okay, so if we look at Michael Jordan's salary here for what this data set has, it's not all the years. In fact, it's only a few of them. So if I do n equals to 20, we can see that it's definitely missing some of the salary, like some of the 80s and stuff like that. I think the salary for this data set actually starts at 1990, which is part of the reason why we don't have all of Michael Jordan's salaries. Okay, cool. So, but now that we have this, what I want to do is I want to take this average points per year or preseason, either one or both. But I'm going to use the per year, this one right here. I want to take this and I want to merge it with this data. So what I can do is call a new data frame. So merged, or let's go ahead and say my actual mean df, as in the mean, the average data frame, is based off of this. So we'll go ahead and do pd.dataframe is that. And what I want to do is reset index. And I'm going to go ahead and say drop equals to false and in place equals to true. Now, just to verify why I'm doing this, we can take a look at the current data frame from that data set. The date is the index right now, which is fine. We could totally use that, but I want to have an easy join. So I'm going to go ahead and get rid of that and reset it this way. So now it's going based off of the year is now a column in here as we sort of intend. So now we can create our merged data frame. Of course, this is going to be taking our mean data frame and then doing merge. Now we're going to grab our player salary data frame and we're going to go ahead and say left on. This is going to be year, and then right on. This should be, I believe we said, our year start. Okay, and now we can take a look at this. And what we see is our adjusted salary for those points of that year. The average points for that year make up for that particular salary, which is cool. I really, really like this. But one of the things that I don't want to have is year start and the year. So I'll just leave the year in there itself. So I'm going to go ahead and drop that column. So we'll go ahead and say columns equals to year start and in place being true. Okay, so after it's merged, we got rid of that. And the next thing would be to actually look at this adjusted salary as dollar figure. So merged df adjusted salary dollar is equal to the merged df adjusted salary dot apply. And this is our utils dot float to dollars, which I imported that at the very top. It's definitely there. And that just really just changes this number into a float formatted number. So I'm going to go ahead and do in ahead of 100, which probably won't be correct. But what we see is something outstanding here in Michael Jordan's case. Okay. One of the things is, of course, we're missing a few years here. That's fine. But what we got is in 1995, I believe he was retired in 94, but in 95, I think he came back. And then in 96, he made almost $50 million. So his salary went up a lot. And that's in relative terms, right? So it's quite a bit different back then. But that's pretty cool. That's a cool way to look at this for any particular user. Okay. And so this is actually where we're going to leave it. We now have really come full circle with a lot of the fake data to this, right? We now have a much better look at what does a user end up making or a player end up making over their career. And this would be an example of that. And how does that correspond to how many points per game they have in that year? Now, the other thing is that I would probably want to do is like number of games played, right? And then maybe having a salary per game, right? So there's a lot of analysis that I can still do with this, something I'm not going to cover at this time. But the idea is now I can actually take a look at a data set of some kind using all the skills that we just learned within Pandas to do some further analysis. Now, again, the actual years here are a little jumbled because of how seasons work with the NBA. So I do recommend that you give this one a shot to improve. And that's definitely something I'd recommend to you as well. Let's keep going. Before we go, I wanted to mention the appendix section for this particular course. Now, if you actually go to our GitHub repo, which of course is linked in the description, you can actually go into the course, into the appendix, and you'll see all of these different notebooks that sort of build up what we did here. Now, I might actually add additional appendix items to this if I get feedback from you guys, and maybe I'll do individual videos specifically for that. So let me know in the description if that's something you would want to see. But the idea here is you can go to any of these appendix items and hopefully run them wherever you choose, right? Whether it's Deepnote or Jupyter or wherever, you can run these to see how it is that I came up with some of the pieces that built up the rest of the course. And I think at this point, you probably have a better foundation on how you might end up needing to do these things or to do them on your own. For example, scraping and building the NBA salary data set. This is something that I think is really well worth your time to go through, especially if you end up scraping data for a different sport and trying to get like different salary data and different information for that. Now, this of course might not always work because I don't have any control over the hoopshype.com or the website that I actually end up scraping. But the point of these notebooks is really for you to just go through them and see how I was able to get some of the data or how I was able to manipulate how I worked with all of this stuff that sort of fell outside the context of the rest of the series. Hey, thanks so much for watching. Hopefully you got a lot out of this one. And of course, thanks to Deepnote for helping make this happen. Now, the big part of this is where do we go from here? And I want to challenge you to actually find a new sport, grab all the data necessary, which would probably include web scraping. I have a link for a video on how to do that in the description. But the idea here is once you find a sport, grab all that data. I want you to actually write your own notebooks that emulate what I did, but hopefully you do it from scratch. Now, the reason you're going to write your own notebooks is it's going to really help solidify in your mind how to do all of these things. Pandas is one of those tools that you're going to want to reference constantly. So if you actually create a notebook from scratch at this point, you will actually have a reference for yourself on how to get back to certain pieces of all of this. Because it's not really a tool like a web application. There's not like a one size fits all how to use Pandas. It's really building up a bunch of projects that over time you will start to have a really comprehensive look of how to make it all happen, because at the core of it, it's really just dealing with that spreadsheet type data or tabular data or table data. So hopefully that helps you actually build your skills even more. Now, of course, if there's something else you want to see me cover in Pandas, let me know in the description. Otherwise, look forward to seeing you next time. Thanks again.